We are going to be writing quite a lot of NeetCode today, and that's because we're going to be learning the core features of the Python programming language. Now, I've mostly used Python for data structures and algorithms because it's pretty much the simplest language out there. But it has quite a lot of applications, especially in machine learning, AI, data science, and even like back-end web development. So there's quite a lot of reasons to learn Python, and it honestly is easier than you would expect. Even if you're just learning it for coding interviews, I think it's well worth your time. Now, you're going to learn a lot from watching this video, but you're going to learn even more if you follow along, whether you want to do that on neetcode.io with these kind of exercises that I've created. It's kind of like an interactive textbook, the way I would think about it, but you can also follow along in your own local code editor. A quick rundown of this environment. Here at the top left, you can click the course name. It'll take you to the menu. You can see at the moment there's 82 lessons. I might add a few more, but at this dropdown, you can go through all of the chapters, and here you can navigate between lessons. You can also go back and forth between lessons with these arrows. On the right, you can change the theme. Okay, we're gonna go back to dark theme, but if you prefer light theme, go ahead. You can go full screen if you want to. You can change a few settings. You can reset to the original code, like the starter code. Here, there's a console. We'll kind of get more into that, as well as the submit button. And on the left, you can see the question itself, as well as the solution. Now, let's get into it. Hello world. This is traditionally how most people learn a new language. The first exercise they ever do is print hello world to the console. You can pretty much do that in every language, and it's a long-held tradition, so I think that's kind of a good place to start. Python makes it very, very easy for us. Python provides a built-in function called print, and we can pass in some text using double quotes. We can also use single quotes, but we'll get into that a bit later. But in those double quotes, we can pass in some text. So whatever we want to print would go in between those. We can see we already have that at the top right. And in this exercise, we want to print this text exactly. Now, capital matters, punctuation, spaces matter. So we want it to be exactly like this. You could copy it, but you could also type it out from scratch. So that's what I'm going to do. Just going to go ahead and type hello world, no capital on the second word with an exclamation point. And then I'm going to click submit. You could also do Control Enter if you want to do the keyboard shortcut. And we can see we have successfully passed this lesson, and we can go to the next lesson. But if you want to learn a little bit more, if you want to learn a little bit more about this course, you can kind of go to this bottom drop down. It'll go through a little bit of the basics I talked about. You can also be a bit more curious and say, well, what does this exactly mean? What does print mean? What is this parentheses, the quotation marks? And you can get a little bit of the background. And I think one thing that's definitely worth mentioning here is the output. Your output is what was printed by your program. This is the expected output, what we expected for you to actually print. And since the output matches the expected output, you have passed the lesson. So that's the way we're going to be testing this. Your output is basically what would be printed to the console if you are executing this code locally. The console is just a place for output and debugging information and things of that nature. When you're ready, go ahead and click the next button here or the next arrow up above and go to the next exercise. What is Python? Well, Python is an interpreted programming language. If you're curious what exactly that means, if you're a beginner, you might not be super interested, and that's perfectly okay. But if you have some programming experience, you might be a bit more curious, and you can go ahead and scroll down to read more about that. But Python is actually an old language. Believe it or not, it was created before JavaScript. People don't expect that because the syntax of Python is very modern. It's very easy to use. A lot of languages have borrowed a lot from Python. I love Python because it's very, very easy to read and simple to use. It's definitely one of the most popular languages in the world, and it is continuing to grow in popularity, largely because of like AI and machine learning. In this course, we're going to be talking about the core concepts. It's perfect for you if you're a beginner, but also if you have experience, there are going to be little things like kind of the things I have below here that you're going to learn and be able to compare to other languages that you might already know. If you're familiar with Java, this will teach you a very different way of programming compared to Java. Now, programming is very, very powerful. You can see the code here on the right. You don't have to understand it yet, but just skimming through it, there's a lot of code that's going on. And what it's doing is computing the digits of pi. Obviously, there's a lot of math here that we're not going to be learning about, but this is very, very powerful. If I submit this code right now, you're going to find our code computed the first 19 digits of pi after the decimal point. But the expected output was actually, we wanted the 20 digits after the decimal point. So how do we get 20 digits? Well, we don't have to rewrite this entire program up above, actually. There is one parameter that we can change. We just have to find this line of code, n equals 19. We can read through the code if we want to find that line. It is right down here, but it's common in programming to have like a bunch of complex code. And if you know what you're looking for, you can actually click into the code editor, press Control F, and then search exactly for the string that we want. So n equals 19 is what we want. That's how we're computing the 19 digits of pi. We want to change that to 20. We want 20 digits of pi. I changed that. Now I'm going to resubmit this code. All we did was change one line, and now you can see we get the perfect output that we wanted. So this is just meant to illustrate the power of programming. You don't have to understand all of this math, all of this syntax that's going on just yet, but by the end of this course, you will understand most of it, believe it or not. In most programming languages, code is executed in order from top to bottom. So on the right, you can see we have 4 lines. The last line is empty, but we have 3 lines that are non-empty. And as you would expect, these lines are going to execute in order. And that's true for most programming languages. Python is no exception. So on the left, you can see if we had these 3 print statements, this is what the output would be. The first one would be printed first, second, and then third. Each of them will be printed on a new line in Python. So in our exercise, we want to print 4th, 5th, and 6th. There's only one problem. On the right, you can see the order doesn't quite match. We first have 5th, 4th, and then 6th. So we just want to reorder this. So I'm going to click this line. I'm going to Control X to cut that line. I'm going to go up top, go to the first line, enter, and now we have this. Now, if I put some spaces or empty lines between these lines of code, that's going to be fine too. Like empty lines don't do anything. They're pretty much ignored by Python. So I'm going to run this code now. And you can see we did get the expected output. So let's go to the next lesson. Now, we talked about printing. We've printed a few times now. We printed hello world. And you probably noticed that we did put the text inside of double quotes. In most programming languages, including Python, this is called a string. Most languages will use double quotes to define a string. But some languages, like Python and JavaScript, actually allow you to also use single quotes if you want to. So like on the right here, you can see me printing hello with single quotes. So this will work just the same as if we had double quotes. That's not always true in every language, but in Python, it is true. Now, what exactly is a string? Well, you can just think of it as a sequence of characters that is placed in between opening and closing quotes. Now, that gets into the question of what if we want to print the quote character itself? So down here, there's kind of a problem because we said characters in between an opening quote and a closing quote define a string. So it looks like we have a string here, right? These are the characters inside of that string. And then after that, we have some text that's hello world. Now this, while it kind of looks like it's in between an opening and closing quote, it's not. This was the opening and closing quote. This is just some text outside of some quotes. And then we have a couple more quotes over here. So this is going to give us an error. Just to prove it to you, I'm going to run the code on the right, which is having a very similar error to the one that we have on the left. So running this, you see we get an error. There is some invalid syntax. Our job here is to fix this error. One possible way in Python and most languages is to use the / character, which is the escape character. So that will tell Python that we don't want to treat this quote as a closing quote. We don't want to treat it as that. We want the character quote itself. So look here, I'm going to add a /, and now it's telling Python we want to treat this guy as a closing quote. Now, this turned red, so we actually still have an error here, and that's because we have one opening quote now, and we have two closing quotes. This is not a quote anymore, it's just considered a regular character, but for us to fix this, we are also going to change this character into a regular quote. So we're going to put a backslash in front of that as well. So now this code, the way Python interprets it is this is an opening quote for defining a string. This is just the quote character inside of a string. This is also just the quote character inside of a string. And this is the closing quote that closes the entire string. It's a little bit confusing when you first learn about it. You probably won't need to use this very often, but it's definitely worth knowing. The escape character is very, very important in programming. So now if you were to actually read what this is saying, my favorite quote is to be or not to be. And now it will be printed with quote characters around the quote itself. So that basically was the error that we were trying to fix. This is what we were trying to print before we had a syntax error. So now if we submit this, you can see it works just as you would expect it. There actually is another solution. This solution is nice because you can use it in most languages, but there is a solution that Python actually allows for, and it kind of has to do with what I mentioned earlier, that we can also use single quotes to define a string. So if we were to do that, we can actually take the string here on the left, and using what I talk about here, we can define the entire outer string with single quotes, a single quote on the left, a single quote on the right, and this itself will work. If I submit this, you will see it does work, but we can also now, inside of single quotes, we can use double quotes as normal. So if I get rid of that and I get rid of that, because Python first sees the single quote here, it scans through here. When it sees a double quote, it doesn't assume that this is going to close that string, because only a single quote can close this string. It sees another double quote here, that's fine, but then it sees the single quote and that closes the opening one. So the order that we put these in definitely does matter. Now, not only do we need closing quotes, we also need closing parentheses. So that's what we're talking about here. We're talking about code errors. We saw one earlier, which looked kind of like this, invalid syntax. And if we run the code on the right, we're going to get a similar error, a syntax error, because Python expects the code to have a certain syntax, kind of like how when we use normal language, we don't really want to have like spelling errors in our documents or grammar errors and things like that. Python and programming languages are the same way, but programming languages are a lot more strict. They're not very forgiving. If you have an error, your program might just not work at all. And when you have an error, you might get a pretty helpful error message like this. Like this one tells us exactly what went wrong. It tells us we had a opening parenthesis, but error. The opening parenthesis was never closed. So that's kind of a clue of what we should do. If you look at the code, we do have an opening parenthesis, but there's not a closing one. So sometimes error messages like this are very, very helpful. Sometimes they're not, but it's always worth looking at the error message if you can't figure out the solution to the problem. So all we want to do in this exercise is print this text. Can someone please add a closing parenthesis? So if you weren't able to figure out the solution, hopefully that serves as a hint as well. We're just going to add a closing parenthesis, go ahead and submit this, and you can see we passed it. There are other types of errors that are not syntax errors. There are runtime errors and logical errors. You can read more about those on the left if you are interested. Comments are a way of adding context to code without actually writing code itself. So in Python, the easiest way to create a comment is to use the pound character, or the hashtag character, as many people know it as. And if you were to do that, so on the right, just play around with it, just try it out. Put a pound, you'll see it turns green. So this means it's a comment in most like code editors when it's green like this. And now we can just type whatever we want. We can add code even. We can add a print statement here, print hello, and it's not going to do anything. This code is not going to execute. So just to prove it to you, I'm going to take all of this, and the shortcut to turn this into a comment is Control/, or at least on Windows. On Mac, I think it might be Command/, but I'm going to turn that whole block into a comment now. when I run this, you're going to see our output is actually empty. There isn't any output. This was the expected output, but our output does not show up because nothing happened here. So comments are ignored. Comments don't do anything in programming, and this is how we can define a single line comment, by using the pound character. Now, if we were to put that pound after, like, we can add a comment to this line without affecting this line. We can actually say here, this prints hello. So we have the line of code, it's going to execute, and we have the comment after it, which is not going to do anything. It's not going to affect this line. If we remove the pound, now we have kind of an error. I think this is going to be a syntax error. Yep, there it is. So I think it's worth playing around with this, but our exercise is going to be specifically, we want to print this text. I belong here, I also belong here, me too. We have 5 lines of code on the right. If you were to reset the code, you can reset the code like this, by the way. So this is the starter code. Now, we want to print this without deleting any of these lines of code. How can we do that? Of course, using comments. Which one do we want to remove? This one stays the same. Why am I here? I don't see that in the output. So let's go ahead and get rid of that by adding a comment. Get me out of here. I don't see that over here either. Let's go ahead and get rid of that as well. And these two stay. Now I'm going to go ahead and submit the code, and we can see that we successfully passed. So this first section was just the introduction. Now it's time to actually get into learning about Python. So we've printed a few strings, and we've realized that we can pass a string into the print function. But if we want to print the same string, we kind of have to type it out from scratch every single time. Is it possible for us to be able to reuse certain strings or just data types in general? And the answer is yes, we can do that with variables. So if we were to save this string, again with double quotes, in a variable called message, we can do that with the equal operator. We're assigning this variable to this string. So now, if we want to print that same string again, we pass that variable into the print function rather than the raw string itself. We can do this multiple times, so instead of typing out the string, we reuse the variable. And the output would be just as you would expect. The string would be printed twice. So we don't have to keep typing out the string from scratch. So as an introduction, you can think of variables as containers that can hold values. In this case, it's storing a string. It can store other data types as well, which we will learn about. Our challenge is to update the code on the right so that it prints this string twice. Let me kind of make this bigger. This string is stored in a variable. That should be printed twice. And we want to do it without modifying anything below this comment. So how do you think we can do it? Well, if we print this right now, we're actually going to get an error. And that's because message is not defined yet. We haven't really created a variable called message just yet. So we definitely want to do that. We want to fix that. And if we want to print this string twice, let me just go ahead and copy it and then put it in between these double quotes. And then when we print, we can see we get the expected output. Now, keep in mind that we didn't put double quotes around the variable itself. If we put double quotes here, the string that this is going to print is going to be the string message. We know it's a variable because there aren't double quotes around it. So that's an important point to know. Now, when it comes to variables, there are some rules. We used a variable called message that works. And as you might imagine, we can't have multiple variables with the exact same name. So if we had a variable called message, we can't create a separate variable that also has the same name. We'll get into what happens when we try to do that later on, but for now, we can't have multiple variables with the same name. Also, we want generally our variable names to be descriptive. So if we wanted to store, for example, the name or the string London, and maybe we want to reference it as the capital of UK. So we're just storing a bunch of capitals and we want it to be descriptive. You can notice we are allowed to have underscore characters in a variable name. Now, there are some things that we can't have. We can have letters, we can have numbers, and we can have underscores. We cannot start a variable with a number though. So that's very important. Variable names also can't have spaces because, if we have a space like message 1, underscore, that's allowed, but message 1, like this is two separate things. So that's why we can't have variables with white spaces in them. And generally, you don't want variable names that have the same name as a keyword in Python. We'll learn more about keywords later, but just know that there are certain special words that we can't generally use. So knowing that, we have a challenge. We have some code on the right that's given to us. We want the output to be these three capitals. So it looks like we're already printing the capital of France and Germany. So without modifying these lines, let's assign those to variables. I'm going to copy and paste that. The capital of France, you may know, is Paris. And the capital of Germany is, you may know, Berlin. So we have the three variables. So we want to print the capital of Spain, which is already given to us here first. So we could do this. We could copy and paste this thing in here, but you might notice a bug. When we try to run this, it might not work as expected. And the error message is somewhat helpful. It does point us to the character that's causing the bug, but if you look at the rules, you'll see variable names can't start with a number. That's very important. So let's get rid of the number in that name. And then when we're printing the variable, let's not reference that number anymore. So this is the expected code, and we get the expected output. Let's go to the next lesson. Now, naming conventions aren't like hard rules that are usually going to cause bugs. It's mostly about styling and just readability. So there are many different ways to name variables. A common way is camel case, where the first letter of every word is capitalized except for the first word. So example, my variable name, the first word is not capitalized. The second and third words start with a capital. Snake case is where the words are lowercase, but they are separated by underscores. We kind of saw that in the previous lesson. And the other one is Pascal case, where every word starts with a capital character. So this is similar to camel case, except the first word also starts with a capital. Now, Python uses generally snake case. So that's what we're going to stick with in this course. It's not the end of the world, obviously, if you use a different naming convention. You might be coming from a language like Java or JavaScript that have different naming conventions. So our challenge here is to rename the variables to follow the snake case naming convention. There's some code given to us. The variables are being printed as snake case, but they're not defined as snake case. So if we want to update the variables, all we have to do is rename them, and we can leave the code below as is. So this is going to go ahead and be like that and like that. Fixing that as well, we get the snake case names and the output as expected. Now, we mentioned two variables can't have the same name. So what do you think this code over here on the left is going to do? We have message assigned to the first message, then it's assigned to the second message, and then we print it. So the output turns out to be the second message. Why is that? Well, it's because when we had this first line, message is assigned to the first message. When we execute the second line, it gets reassigned to a different value. We didn't create a second message variable. We created an assignment, a reassignment, so that the value of message was updated. So messages or variables can be reassigned in Python. Now, the order that we put these statements in definitely does matter, though. If we had reordered the statements like this, if we printed it before we assigned it to the second message, as you would expect, the print would have printed the first message because it was executed before the reassignment on this line. So the order definitely does matter. Now, our challenge is, can we add a single line of code to this starter code over here such that we print the first message, the second message, and the third message? Well, let's just read the code. Reading code is a very, very important skill To learn, it can be even more helpful than writing code. So we have a message, the first message, it's printed. Then we print again. As of now, you can guess what this code is going to do. It's going to print the first message twice, then it's going to reassign it to the third message and print the third message. So obviously the bug is that instead of printing the first message twice, we want to print the second message. Where do we put that line of code? Probably before the second print. So over here, I'm going to reassign it to the second message. Rerunning the code, we can see the output is correct. Now, Python also allows you, like most languages, to assign multiple variables in a single line, and the syntax is a little bit different than other languages. We want to have the variables all on the left side of the equal sign, and they're going to be separated by commas. In this case, we have two variables, message1, message2. On the right side of the equal sign, we're going to have two values. They're both strings in this case, and the first one is hello, the second one is world. As you would expect, message1 gets assigned to hello, message2 gets assigned to world. So this code is equivalent to the code down below. It's just that this one is a bit more concise. Also, as you would expect, we want the number of variables on the left to match the number of values on the right. Otherwise, we're going to get an error. It's pretty neat in Python that you can actually use this idea to swap values. So here, the first line of code is going to assign message1 to hello, second message is going to be world. Now, we can reassign these in a single line as well. We can set message1 to message2, and message2 can be set to message1. In other languages, you might need like a temporary variable to do this, but Python allows you to do it without a temporary variable. So this is very concise syntax to swap these two variables around. So now our challenge is to update the code on the right so that it prints the following: hello world, my name is. And if we want to do this with multiple assignments, we can get away with doing this with just a couple lines of code. So let's see what the code that's given to us. We have message 1 printed, message 2, 3, 4, and 5 printed in that order. We're not allowed to change the code down below. We're also not allowed to change the code up above this line. So what we have to do is kind of swap these variables around. Message 1 should be hello, like that's what we want in the output on the left. So how do we do that? Well, we could just say message 1 is equal to hello, or we could set message 1 equal to message 2. We might also then want message 2 to be equal to world. So you could say, obviously, message 2 is equal to world, or you could set message 2 equal to message 1, but actually this is a bug. Look very carefully at what we're doing. Message 1 gets assigned to message 2, which is hello. So now both message 1 and message 2 are hello. So if we set message 2 equal to message 1, well, message 1 is hello right now, right? This line executes before this line. So this is kind of a bug. But if we swap these two variables on the same line of code, we can avoid this bug. So we can set it like this. Now these will be swapped at the exact same time. So message 1 will be hello, message 2 will be world. And we want to do similar stuff with this line here. We want message 3 to be my, message 4 to be name, and message 5 to be is. So message 3 is going to be assigned to message 5, which is currently my. We want to then swap the other two on the same line as well. So message 4 is going to be assigned to name, which is stored in message 3. So that's going to be over here. And lastly, message 5 needs to be is. So message 5 is going to be assigned to this one, which is message 4. This is kind of challenging if you're a beginner or if you're just new to swapping variables like this in Python in general. Now let's run it, and you can see it does work. Now, so far, we've only looked at strings, but variables in Python can actually have many different data types, including integers, as you can see here. So we have a variable assigned to an integer value 25. We also then have another variable temperature assigned to a decimal value. In Python, these are called floating point numbers because they have a point that floats, and there's more reasoning behind it, but we won't really get into that. We can also have Booleans, and these are very, very important in programming. We're going to learn more about them later on and some Boolean logic along with that. But for now, Boolean values are kind of binary values. They can either be true or false. This one is assigned to true. We also have strings, which are defined with an opening and closing quote. And we also have lists, actually. So these are like a sequence of values. This one specifically is a sequence of integers. We'll learn more about these later on as well. Now, if we want to get the type of a value in Python, there's actually a built-in function for us to do that. It's called type. So we can pass in 10 into the type function and then print whatever the result of that happens to be. And the output in that case is going to be integer. Right now, we want the output of this code on the right to be type int, float, bool, string, and list. How do we do that? Well, it looks like we're getting the types of variables that aren't even defined, and the names of these are going to kind of give us hints. So obviously we want integer type to be assigned to an integer, and we kind of see how that's done over here. So let's just go ahead and do that. Integer type is going to be assigned to a value. It could be 25, but it could be any integer. So there's a hint down here telling you that the values don't matter, only the type matters. So just to prove that to you, I'm going to set this actually to 0. And I'm going to have another float type, and that's going to be set to a float. We know that this is what a float looks like, but it just needs to have a decimal point. So to prove that to you, I'm going to put 0.0. That's technically distinct from 0, the integer. This is a different type. Next, we're going to have the bool type. So that should obviously be a Boolean. It could either be true or it could be false. And to define false, there was like some wording down here. So it does need to be capitalized. This can be true or it can be false. It needs to be capital. If I get rid of that, you can see the color changes. That's a hint to us that true and false are important words in Python, and they need to be defined with a capital. Next, let's do the string type. We're pretty familiar with this. So the variable names, by the way, I am just getting from what is printed down here. So this is going to be a string. I'm going to make it an empty string because an empty string is still technically a string. Next, I'm going to have a list. It's called list type over here. I'm going to make it an empty list. It's defined with an opening and closing square bracket as mentioned over here. So we can put some values in. I guess I'll put 1, or we could make it empty. It'll run the same way because the type is still a list. Now let's go ahead and run this code. And you can see the output is what you'd expect. It's an int, a float, a bool, string, and list. That is what the expected was, and that's what we ended up printing. Obviously, if I were to make this a different type, if I made it a string, we would have gotten the type of this printed as a string. That's not what we wanted. We wanted it to be a list. So learning a little bit about different data types in Python. In programming, there is this concept of dynamic typing. In Python, the type of a single variable can actually change. We initially assign this variable to 10. It's an integer. Then we reassign it to hello. It's a string. And then third, we assign it to a list of numbers. And this is perfectly okay in Python. If you're coming from Java or C++, it's not okay in those languages, right? So those are statically typed languages. Python is a dynamically typed language. The type of a variable can change. If you look at this Java code, it will throw an error. In Java and some other languages, you cannot change the type of a variable. It's an integer initially, and then we try to assign it to a string. It throws an error. So in this challenge, what we want is to again print a lot of types, but this time we have a single variable. And for us, obviously, to print its type and have it be this sequence of types, we should probably reassign the variable. So initially, we want it to be an integer. I'm going to assign variable to be 10, and then we want it to be a float. So before the second print, I'm going to assign it to 10.0, or I could do, 3.14, just make it a decimal. Next, we want it to be a Boolean. I'm going to assign this time to be true. Next, we want it to be a string, so I'm going to assign it to be an empty string, or maybe ABC for fun. And lastly, we want it to be a list, so let's set it to, this time not a list of numbers, just for fun. I'm actually going to make a list of strings, so that's also allowed. That's technically still a list in Python. So printing all of these, we should get the corresponding types, which we do. So let's move to the next lesson. But actually before that, is dynamic typing a good idea, do you think? Generally speaking, it's not if you can avoid it, because in large code bases, it's kind of unpredictable what the type of a variable is. If it's going to be changing from an integer to a Boolean to a string, then it becomes unpredictable, the type, and it becomes unpredictable about how we should use it without having an error occur. And we're going to learn more about that later. So, those languages like Java and C++ that have static typing, there is definitely a benefit to static typing. It can make the code more safe, less error prone, but it's also a little less flexible. So these are just trade-offs between programming languages. Now we can actually convert one data type into another type in Python. So for example, if we have a variable that's 10.9, it's obviously a float. We can actually convert that into an integer by passing it in to the integer function. So we pass it into integer and then we print the result and we get 10. When we take a floating point number and pass it into the integer function, we're basically stripping everything past the floating point. So in a sense, you could say we're rounding the number down into an integer. 10.9 will become 10. 10.1 would also become 10. In this challenge, we want to update the code on the right using typecasting to print 3 and to print 2. We can't modify these two lines and we can't modify these two lines. We see we have a variable pi, it's 3.14. Right now it's going to print 3.14 in those decimals, but we want it to print 3. We have square root of 8, it's this decimal number, 2.8. We want it to print 2. That's what we want the output to be. Now you can guess how we can do this by taking pi, reassigning it to the integer version of it, so rounding it down. So this will be 3 now. And same thing with square root 8. We want it to be rounded down. We'll assign it to the integer version of that number, and then we'll submit the code, and we see the output is what you would expect. Now, even though we can convert some types, like we can convert decimals into integers, we can't convert everything into an integer as you might expect. For example, if we have a string called hello, like that's the value it's assigned to, if we try to convert it into an integer, how is Python supposed to do that? There might be some built-in rule, but in this case, there's not. So Python is going to cause a type error. We can't convert a string like this one into an integer. So right now, the code that's given to us is going to throw an error. Let's run it just to confirm that. Yep, looks like we have an error, value error. Can't convert this into an integer. So we want the output of this to be 10, and then it's going to print the type of a string, and then it's going to print 10, and then it's going to print the type of an integer. So we're not allowed to modify the code below this line. What is it doing? It's printing variable and then the type. This might seem confusing at first, right? How are we supposed to print 10 and the type of that variable is also going to be a string? Well, why can't we put 10 inside of the string? This is kind of challenging if you're a beginner. If we were to do this, it's still going to print the string 10, but the type is also going to be a string. When we then convert that variable into an integer, this time it's actually going to work. So this lesson is designed to show you that we can convert strings into integers only if the string itself represents a number. So now that we've changed it to 10, The conversion here will turn it into an integer, and then we'll print the integer. It'll still be 10, but the type of it will this time be an integer. Now let's go ahead and run this code, and you can see we get the expected result. This is pretty challenging, but it's just designed to show you, like, if you're not able to come up with this by yourself, that's okay. I just think, learning it this way is a little bit easier than if I just kind of explicitly tell you, because now you're probably going to remember it a lot better. There is also an empty variable in Python. In many languages, it's called null, and I kind of prefer that. Let me type it out. It's called null, N-U-L-L. In Python, though, it's not called that. It has a different name. It's called none, capitalized, N-O-N-E. So you can see that this is a key word. It turns blue. And this is used basically to indicate the absence of a value. So it's not a data type of integer or float or string or any of that. This is an absence of a value, a variable that doesn't have any value assigned to it. So in Python, if we try to just have this code, like if we have a variable that's not assigned to anything, it's actually going to give us an error. So if I run this code, you're going to see we get an error. This variable is not defined, but we don't want to assign it to anything. So the way to do that is to assign it equal to none. So now we still haven't really assigned it to anything other than, this itself, none, but this will not give us an error. So if I submit it, we see we got the wrong answer, but it didn't throw an error for us. So this is the expected output. You can kind of guess based on that what we want to do. We want to print the type of this, none type. So we have this variable. Let's print the type of this variable, and I'm going to go ahead and do that and submit it. So we kind of passed this without even reading what the challenge was, but that is indeed the solution to this. One of the core things that we can do in programming is arithmetic. So that's kind of why they're called computers. They compute numbers, and they do it really fast. Like, no human is going to be able to compete with a computer when it comes to arithmetic. We have a lot of the core math operations, adding two numbers together with the plus sign, subtracting the second number from the first with the subtraction sign, and multiplying two numbers not with the X character, but with the star character. On my keyboard, I can type this character with Shift 8. On yours, it might be a little different. Division is just the /. And the interesting thing about division is that the result is always going to be a float. So taking a look at the example here, we have two numbers, x is 3, y is 6. Add them together and print the result, we get 9. Subtract y from x, and we get 3 minus 6. That's a negative number, that's -3. Negative numbers are fine in programming. And we multiply these two, 3 times 6, we're going to get 18. We divide 3 by 6, we get 0.5, as you would expect with decimal division. If we were to do the reverse, though, if we were to say y divided by x, that's 6 divided by 3, the result will be 2.0, not 2. Most of the time, this isn't a big deal, but it's worth knowing that the division operator will always give us a float as the result. Now, for the other arithmetic operators, the result is going to be an integer if both of the operands is an integer. So for these three, we had integers as the result. Now, if one of these, like if this was 3.0 or y was 6.0, the result of these three operations would have been a float. If one of the operands is a float, the result will always be a float. This is a pretty subtle point that I'm making. Most of the time, it's not really super important, but it's definitely worth knowing. Now, you might be wondering about the order of operations. If we have like a really big math equation that we put on a single line, what would be the order of operations? The good news is that it's pretty similar to the math concepts that you're already familiar with. In the US, the acronym is PEMDAS. To be honest, I never really learned this, but I think it's pretty popular. But if you don't really care about that, this is the order. We can put operations in parentheses. Those will always evaluate first. We can have exponents. We'll talk about these in a bit. And then we can have multiplication and division. These will execute from left to right. And then we can have addition and subtraction. They have the same precedence, and they will also execute from left to right. So if you look at this expression really quickly, 2 plus 3 times 4, the multiplication goes first, and then the addition. 3 times 4 is 12, plus 2 is 14. If we want the addition to go first, we can put it inside of parentheses. 2 plus 3, that's 5 times 4 is 20. This is definitely important. If you're not sure about the order of operations, it's just best to use parentheses. That usually makes the math more readable anyway, so parentheses is kind of the easy way out. Now, for our challenge, we're going to do a few things. We want to print the following: the sum of all of the values given to us. That's pretty easy to do. Before I even read the rest of this, I'm just going to go ahead and do that because that sounds pretty easy. Let's do A plus B plus C. Those are the variables given to us. There are a couple integers and one float. Number 2, we want to do 0 minus the sum of the values. Well, that can be done pretty easily. Let's say print 0 minus all of these, A plus B plus C. This works. Now, there is a hint. We're free to declare variables if we want, and variables are going to be pretty useful. So this is kind of the power of a variable. It looks like we're using the sum of all of these and we're printing it, and it looks like we're using that sum once again in the second print statement. So let's just put that in a variable. I'm going to call it sum. If you try to do that, you see that this is actually a keyword. We'll learn a bit about that towards the end of this course, so I don't want it to conflict with that. So I'm actually going to call this total sum, and I'm going to assign it to these 3 values added together, and then we'll print the total sum in the first statement, and then we'll print 0 minus the total sum in the second statement. Now let's look at the other ones. We want to third print the product of all 3 values. Let's do that once again. So down here, let's do A times B times C. That's the product. And fourth, we want the sum of the values divided by the product of the values. So it looks like we're using the product a couple times. It's probably good to have this in a variable as well. So that's what I'm going to do. I'm going to have total product up here. And then we're going to print that for the third statement. And fourth, we're going to take the sum of the values, total sum, divide that by the total product. So now we have this, and this is some pretty clean, readable code, right? The fact that we used variables made the code pretty nice and easy to read. So let's run this now, and we get the expected result. You can verify all of these if you want, like using these numbers, if you're a big math person. If not, you can go ahead and move to the next lesson. Now, there's a few more math operators in Python because there's a few more math operations that are pretty common to do. So one is floor division. In a lot of languages, this is the default way to divide numbers. Python's a little bit different. So what we mean by floor division is, for example, that's the best thing to usually do. Just kind of read the example down here. So that's what I'm going to do. We have 7 and we have 2. If we take 7 floor divided by 2, we get 3. If we did regular division, it would have been 3.5. With floor division, we get 7 divided by 2 is 3.5, and then we round it down. So double slash is floor division. It rounds the result down. The result will always be an integer with floor division, not a float. Third, we have the modulus operator. Usually people call it the mod operator for short. It's the percent sign. It will take a number, 7, divide it by 2. So 7 divided by 2 is 3 with a remainder of 1. So modulus just gets us the remainder of division. So 7 divided by 2 leaves us with a remainder of 1. If we did 8 divided by 2, the remainder is 0, and that's what the modulus operator would return in that case. And third, we have the exponent operator. In Python, the easiest way to do it is double star. So this will take, down here, x to the power of y. So x with an exponent of y. In this case, we have 7 raised to the power of 2. That's just 7 squared. The result of that is going to be 49. Now we're given 3 variables here, and we want to once again print a bunch of computation. And quickly, what's the precedence of these operators that we talked about? Well, again, it's pretty similar to just math rules that you might be familiar with. The highest precedence is the exponent, and then floor division and mod are going to go after that. And these two basically have the same precedence as multiplication and division. But again, if you're ever confused, it's best to just use parentheses. Even I do that, and honestly, most people do that because it makes the math more readable. Now let's get into the challenge. First, we want to print the product of A and B floor divided by C. We may or may not need a variable. I think we might, so I'm going to go ahead and just start with that product A, B. So I'm going to get A times B. And then we're going to print the product A, B, floor divided by C. So double slash divided by C. Next, we want the remainder. So we want to use the modulus operator. We want to mod it. So take the product A, B, mod it by C. Third, we want the result of raising A to the power of B. That's pretty easy to do. A double star to the power of B. Fourth, the result of raising B to the power of C. Once again, pretty easy. B power of C. Just to note, this will not print what you expect. A caret B is not A to the power of B. Just keep that in mind. That's not that, like a lot of people make that mistake. So that's not going to give you the result you would expect. This is how we do exponents in Python. Now let's go ahead and run it, and we get our expected result. There are some shorthand operators in Python. So if you look at the following code, count is assigned to 0, and then we add count with 1 and assign it to count. So this will just increment count by 1, so now count will be 1. Then we will set count plus 2 equal to count. So now we're adding 2 to the result. So if it's 1, then the total now is going to be 3. When we print it, the value is 3. So we are allowed to use the same variable in its own assignment calculation. But there's actually a shorter way to write this code in Python, and this is similar in other languages. We can use plus equal. So count is assigned to 0, and then we say plus equal 1. This basically means we're adding 1 to count. And then we do plus equal 2. This just means we're adding 2 to whatever count already happens to be. So if it's 0, we add 1 and then add 2. The result is going to be 3. So this code is exactly equivalent to the code up above. This isn't just true for addition. The shorthand operation for subtracting is minus equal. For multiplying is times equal. For dividing is slash equal. And you can do that with modding, floor division, and exponents as well. Now, these are not required, so if they're confusing to you as a beginner, that's okay. You're not required to use them. And most of the time, the only common ones that you'll see are plus equal and minus equal. Those are the most important ones anyway. We'll at least practice using those. So our challenge is there's a variable given to us number. We want to use the shorthand operators to add 5 to number and then print the result. So that's not super crazy. Let's just review the syntax. Plus equal. So number plus equal 5 and then print it. That we can do pretty easily like this. Okay, step 1 is complete. Step 2, subtract 2 from the number and print the result. We have minus equal for that. So we're going to do number minus equal. What did they want us to do? I think it was 2. So subtract 2 from number and then print the result. Third, add number to itself and print the result. Whoa, that's kind of interesting. So to number, we set number equal to number plus number, right? Like that's what we mean. We're adding the number to itself and then assigning that to the result. This is perfectly valid, and the shorthand version of this is also valid. Plus equal to number. That's adding number to itself and then print the result. We'll run it, and you can see we do indeed get the correct result. Now let's learn a little bit about Boolean algebra. It's a branch of mathematics. We're not going to be going super in depth into it, but we're going to learn what we need to know for programming. In programming, there is something called the logical OR operation. It takes a lot from Boolean algebra, and the idea is very, very simple. So suppose we have two variables. One is assigned to true. So by the way, Boolean algebra deals a lot with binary. It deals a lot with Boolean values, as you might imagine, so true and false. So if we have one variable assigned to true, a second assigned to false, if we say A or B, logic OR, we're basically asking either A is true or B is true. And if one of those is true, then the output is going to be true. So in this case, that is the case. One of these is true, so the output is true. If both of them were false, the output would be false. If both of them are true, the output would be true. It's similar to English. So first, I'm just going to kind of explain like the English way of saying it, like how human language works. If we say Alice likes ice cream, and we say Bob does not like ice cream, then we say Alice or Bob likes ice cream. That statement is true because at least one of them likes ice cream. If both of them like ice cream, it's still true to say Alice or Bob likes ice cream, even though maybe the more technical way to say it is Alice and or Bob like ice cream. Now, the more mathematical way to look at it is with something called a truth table. These are all possible combinations of A and B, and the result of them, the logic or result of them. So if both of these are false, the result is false. If A is true and B is false, the result is true. If A is false and B is true, the result is once again true. If both of them are true, the result is also true. It's just asking at least one of these is true, the result will be true. That's all it's saying. Here, we can even have three of them. If we have A, B, and C, the first two are false, the third is true, and we chain these together, A or B or C, the result is true because at least one of these is true. In this case, we have a few variables, 4 of them exactly, given to us, and we want to print the following things. We want to print the logic OR of A and B. We can do that with the keyword OR, as we saw. So we can say print A or B. We could have stored this in a variable if we wanted to. This time I'm not going to do that, but you're free to do that if you want to. Next, we want to do the logic OR of B and C. So B or C. Third, we want to do logic OR of C and D. So C or D. And lastly, we want to do the logic OR of all of them. And we are going to do A or B or C or D. The result of the first two should probably be false. The result of the second two should be true. The result of the last two should also be true, and then all of them together should be true because at least one of them is true. So in the output, we'll get false and then 3 trues, and it looks like that's exactly what we get. And so we've completed this challenge. If you're curious, what is a keyword? Because we haven't explicitly talked about that. Keywords are basically words that are reserved in a programming language. So in Python, the word OR is reserved because it has a special meaning. It's going to take the logic OR of the two operands. False is a keyword and true is a keyword. We can't assign a variable to true because this is already reserved for the value true. So if I submit this, we're going to get an error. Right? We're not allowed to do this. We can say the same for OR. We can't use that as a variable name. So we did talk about this in the variable naming lesson, I think, but now I hope it makes a bit more sense. Now, in Python, there's also a keyword called AND. It's used to perform the logic AND of two operands. So this is similar to OR, but it's kind of the opposite. So if we have A assigned to true, B assigned to false, if we say A logic and B, we're asking are both of the operands true? In this case, they're not both true, so the output is false. In like the human language way, we would say like Alice likes ice cream, Bob does not like ice cream. Then the statement Alice and Bob like ice cream is false because both of them don't like ice cream. They both need to like ice cream for that statement to be true, and they don't, so it's not true. Now, the truth table for and is going to look something like this. When A and B are both false, of course, A and B are going to be false, like the value is going to be false. If A is true, but B is false, the output is false. If the other one is true, but A is false, then the output is again false. It's only true when both of them are true. To summarize, the AND operation returns true if all of the operands are true. So here, if we have 3 operands that are all true, and we take A and B and C, the output is going to be true. In the code editor, we're going to have a very similar exercise. So we're given 4 variables. We're going to print the logic AND of A and B. So A and B, and then we're going to do B and C, and then we're going to do C and D. And lastly, we're going to do A and B and C and D. We probably expect this last one to be false because not all of them are true. This one should be true because these 2 are true. And the first 2 are going to be false because A and B, they're both false. And these 2, one of them is false. So we should get, I think, false, false, true, and then false. And that is exactly what we get. So we're done here. Now, last one for math. There's an easier Boolean operation, actually. The easiest of them all uses the keyword not. And this is used to perform the logical not operation, also known as negation. So it basically takes the opposite of a Boolean value. So if we had A is true and we take print not A, it's going to take the opposite of A. It's true, therefore we're going to get false as the output. With B, it's already false. So we take not B and we get true as the output. So very, very simple. Just take the opposite of that. I'm sure you can think of some human language ways of saying this. Like if I say I don't like ice cream, that obviously means I don't like ice cream. And if I said I don't not like ice cream, that's kind of the opposite of that, even though it gets really confusing with human language. We can also combine operators. So if we were to take this, A and B, that's obviously going to be false with these 2 operands. But then if we take the negation of that, we take the negation of false, we get true in the output. Since we had parentheses here, the AND operation was performed first, which gave us false, and then we got true as the result. So now let's take a look at these and do them. So the negation of A, pretty easy, print not A. The negation of C, not C. The negation of the logic AND of A and B, we're going to get first, let's do the logic AND of A and B. A and B. Now we want the negation of that. So let's say not and then wrap this in parentheses. Fourth, the negation of the logic OR of B and C. So print B or C and then wrap those in parentheses and then let's do not in front of that. We did all we wanted to. Let's print it and the output is correct. Very quickly, what's the order of operations of these? You can briefly read about them here, but in my opinion, it's best to use parentheses just so you don't have to remember these and you don't end up confusing yourself or another developer who has to go and read your code. So we learned that values can be stored in variables and then those variables can be reused later in the program. Well, functions are kind of an extension of this because they can store blocks of code that can be reused multiple times. So if you look at the code down here, this is how we define a function in Python. We use this keyword def, it stands for define, I think. I'm not actually 100% sure. Then we give the name of the function. So we probably don't want to have a variable with the same name as the name of a function. But after that, we put a couple parentheses and then a colon. So this is the function header. it defines the function, and then the code below that belongs to this function. This time we only have a single line of code. It just prints hello world. Functions obviously can have more than just a single line of code. If we wanted, they could have like 2 print statements. The important thing is, though, that the indentation here matters. This belongs to this function only because it's indented. Now, it's common to have 2 spaces or 4 spaces in Python. This time we are going to be using 4 spaces, and we're going to use that throughout the course. That's the most common amount to indent in Python. Now, this code itself is actually not going to print anything by default. This just creates the function. If we actually want to invoke the function, call the function, we do it like this: greet followed by the parentheses. So this is calling the function, and it's going to execute that print statement and print hello world. So it's not that different from how we used the print function earlier, right? This is a built-in function. Print is built in, but we defined our own function called greet, which is only going to print hello world. The challenge for us is this. Right now, we're calling 2 functions. We're not allowed to modify this code. We're calling greet and we're calling say goodbye. Now, the problem is the greet function has a bug. It should print hello world, but it looks like there's a bug. Can you spot the bug? It looks like the indentation. It can be fixed just by pressing the tab character. By default, it will space by 4 spaces. So that's what I'm going to use. Now we have fixed it. Now this will print hello world. That's good, but there is a second bug. When we invoke say goodbye, this function isn't even defined anywhere. So we have to fix that. We have to define this function, and it should print goodbye world. If you don't remember how to define a function, the good thing is there's a function right here for us to follow. So we're going to define the function. It's going to be called say goodbye, followed by parentheses and a colon. When you press enter, you see it actually already tabs by default. That's the power of a code editor. Now we want to print goodbye, comma, capital W, world, and then exclamation point. So now both of these functions should execute, and that is indeed the case. Now, variables have to be defined before they can actually be used, and the same is true for a function. So here you can see we call print and pass in n, but n is equal to 10, and it's not assigned until after this print statement. So this is going to give us an error because n isn't defined yet. Down here, we're going to get a similar error because we're calling print number. It's a function that we define, but that function hasn't been defined yet. So we want the print statement to go after the function definition. So we're going to go ahead and fix a bug related to that. So our challenge is to print 10 and 20. You might not know exactly what's going on here. You might not know why we have an n in these parentheses. That's okay. We can still fix the bug. We see that the function is being called 2 times before the function is defined. So we want to take these lines and move it after this function. But look, if we do this, this is a problem. We don't want these print statements to go inside of the function because then they belong to the function. We want these to be outside. So we don't want them to be indented. So these are going to be like this. The function is defined, and then the function is called twice, printing 10 and 20. So let's run this, and you can see we get the expected result. Now, you might have noticed in the previous lesson, as well as when we're calling print, we always put values and variables inside of the parentheses. That's because functions can be defined with something called parameters. So let's look at an example of that. This is a function, it's called greet. It takes a variable as a parameter. It's called name. And then inside of the function, we create a variable called message. We take hello, which is a string, add it with name. This is an example of string concatenation. We're going to learn a lot more about this, but for now, it's pretty simple to just assume that it's going to take 2 strings and combine those strings together. And then it's going to print that string. So when we call greet and we pass in a string called with a value of Alice, it's going to then inside of here, it's going to take hello, comma, space, plus Alice, and then print that. So this will print hello, Alice. The power of this is that we can take one function and reuse it for multiple purposes. This function can be used to greet not only Alice, it can be used to greet a lot of different people. All we do is pass in a different variable or value in the parameter position. A subtle thing to mention is that this variable is called name. It's the parameter. When we pass in a value for that parameter, it's referred to as an argument. So it's not super important to know. It's just something that you'll hear a lot. So I think it is worth mentioning. Like, what's the difference between a parameter and an argument? But again, it's not a big deal. A lot of people use those words interchangeably. So our challenge here is to define a function called farewell. It takes a single parameter and it prints goodbye, comma, space, followed by that parameter. Then we want to use the function so that the output is this. So right now we have some code. It calls farewell, even though the function isn't defined. Our job is going to be to define that function up above. We want it to take an argument, a parameter. So I'm going to call it name because that seems to make sense in this context. And then we want to create a message similar to what we did over here. A message is going to be equal to goodbye, comma, space, and then the name itself. So adding it with the argument or parameter, and then here we're going to print the message. We're not allowed to modify any of this code, but we still want to print goodbye Bob and goodbye Charlie. The easiest way to do that is just to invoke the functions. Passing in Bob for the first time and passing in Charlie for the second time that we call the function. So now let's run this, and you can see we get the expected result. Functions actually can take more than just one parameter. So down here, you can see that we define a function called greet. It takes two parameters, one called name and another called greeting. And it's going to take greeting, add a space to it, and then add name to it. And then that's going to be assigned to message, and then that's going to be printed. So just another example of string concatenation. The plus operator is going to combine strings together. So down here, if we call greet, pass in Alice for the name and hello for the greeting, the result we're going to get is hello space Alice. So one thing to note, the order that we pass these in matters. Name is defined first, so name is going to be assigned to Alice. Greeting is defined second, so that's going to be assigned to hello. Our challenge here is to define a few functions. One is called twosum, and another is called threesum. The twosum function should take two parameters and print their sum. The threesum function should take three parameters and print their sum. So we can see how these functions are going to be called. 10 plus 9, and then 5 plus 14 plus 6. So let's go ahead and define them. The name is going to matter here. Obviously, it needs to be called twosum. And I'm going to call the parameters, I guess, num1, num2, but you could call them whatever you want. All we want to do is print the sum. So print num1 plus num2. And similarly, threesum, num1, num2, and num3, and then print the sum of all of those. So far, so good. You might think you're done here, but there's actually one more ask for us in the challenge. We want to finally call twosum, passing in 7 and 10 as the arguments. So I'm going to do that here because we're not allowed to modify anything below this line. So here is where I'm going to put twosum, passing in 7 and 9. Now, the order that we pass in these actually doesn't matter. I think I misspoke. It's 7 and 10. Sorry about that. The order that we put these in doesn't matter in this case. Sometimes it could matter. It's not going to affect the result of the sum of these, but depending on what we were doing in here, it could matter. Here, we're going to do threesum, passing in 3, 5, and 8 as the arguments. So 3, 5, 8. And running the code, we can see we get the expected result. Now, another core part about functions is the return statement. Functions are actually a bit more extendable than you might think. We can do more than just print the value. We can return the value. So here, add is going to take x and y and not print the sum, but it's going to return the sum. So now we can actually take that function, pass in 3 and 5, and it's going to return 8. So then when we set result equal to the result of this function, it's going to be assigned to 8. So we can take that value and now reuse it. We don't just print it a single time. We can now reuse that value throughout our code. And of course, the first thing we're going to do is print it, and the result is going to be 8. So this allows us to basically use a value outside of the function it was created in. So our challenge is to create a function called product that takes 2 parameters and returns the product of them. This is the test code. We're not allowed to modify below this line. So you can see we're calling product on 2 and 4, 8 and 2, and a bunch of others. And then we're printing the result of that. We should not put a print statement inside of the function. So we want this product pass in. I'm just going to call it A and B for short. And then I'm going to return A times B here, just like that. So I'm going to run this, and we get the expected result. Now, there's another component to Python called type hints. These are pretty much optional. You don't need to use them, but they can make our code a lot more readable. It's basically a way of kind of adding a comment to a function to say that the parameter that x should be is an integer. So you can see the syntax is the parameter name, colon, and then the type, which in this case is an int, and then comma, y colon int. So the variables are still separated by a comma, but we have a type hint for the parameters, and we actually have a return type as well. So after the closing parenthesis and before the colon here, we have arrow, like dash greater than sign, I guess, but this kind of represents an arrow, and then the return value is going to be an integer. So this adds a lot of information to the add function, making it pretty clear that we expect to have integers as parameters, and the return value should be an integer. In Python, though, these are not like mandatory, in that if you were to pass in a Boolean or a string for x and y, it's perfectly allowed. Python is not going to throw an error in that case. In a lot of languages, the parameter types are enforced. Python does not enforce them. It's just for developers to kind of know. It's possible that functions don't return anything. So a function like this one down here, where we're just printing something and we don't return anything, the return type is actually going to be none, because we're not returning anything, so that represents the absence of a value, and none represents exactly that. So if you want to confirm this, let's do that with the next challenge. Let's call the function greet here, which doesn't return anything, and that's what the type annotation represents, the return type. So let's call greet, and let's pass in a string. It doesn't really matter what string we pass in. Actually, it does. It looks like here they say call the function with the argument NeetCode. So let's do exactly that, NeetCode, and then let's get the return type. So we can get that with the type function that we used earlier in the course. Then let's print the result of that. So this is going to give us probably the none type. Let's just confirm. So it prints hello world. We expect that because we did call the function, and then it prints none type, which again, we expect. Now it's possible that we can actually change this code. Like we can, from the function itself, return none. So let's see what happens when we do that. Is that going to change the output? It's actually not going to. We have the exact same output. We could have also just had an empty return statement, which doesn't return anything. And that's the exact same as returning none. So there's 3 different ways that a function can return none: by not having any return statement, by returning none, and just by having an empty return statement. That's kind of what is mentioned over here as well. One of the difficult things for beginners to understand is this concept of scope, and I'll do my best to explain it, but it might take a bit of time to wrap your head around. Let's look at the following code. We have a variable n assigned to 10. If we print it, of course, we get 10 in the output. Then we define a function called printNumber. The name of the parameter is also n. This is kind of confusing because we're not allowed to have the same variable defined multiple times, right? So what's this code going to do? Well, this function is just going to print that number, and we're going to have this function called with the value 11, which is going to print 11, as you would expect. Then we try to print n one more time, and the output is 10. When we print this value, we're printing this variable up here. Basically, n was never reassigned to 11, even though when we printed it from here, it was 11. So this is kind of confusing. I'm going to try to explain it visually. So this is all about the concept of scope in Python. So when we originally defined n equal to 10, it's a variable. We defined it in something called the global scope. So this represents the global scope. That is kind of the scope that's everything. Like that encompasses the entire scope of the program. Then we had a function. So I'm going to use a different color for that. We had our function. I forgot what it was called. I think it was called printNumber, but this is the scope of that function. So I'm going to try to make it as clear as possible. This is just a single function's scope. Now you can see the scope of that is inside here, but that function accepted a parameter called n. So the scope of this is separate from the global scope. It had another parameter which was called n, and it was assigned the value of 11. So there's a conflict. There's two different n's. There's an n in the global scope, and there's an n in the scope of this function. So if there's a conflict, the function will use its own scope. So whether it took a parameter of n or the function maybe defined its own variable n, it's going to use its own variable. So there's a conflict, it's going to use its own. That's the idea I'm trying to get across. N was not reassigned. This function did not touch this n. It created its own n. So in a sense, there were multiple copies of the same variable, like there are multiple copies of n. Basically, it comes from the consequences of scope. So that's what I'm getting at. This is what happened. So when we called print n inside of the function, we printed 11. But then when the function was done, when the function was finished executing, this function goes away. And then we called print out here. We called print n in the global scope, and that's not going to print the value from the function. It's going to print the value n in the scope of like the current scope, the global scope. So then we print 10. So knowing that, this code makes a bit more sense, right? The original n 10 was not modified. So going down here, I kind of explained the same thing with words. In our case, the challenge for us is to just prove that n inside of the function is a different one outside. So let's look at the following code. Add 1, it takes a parameter called n, it adds 1 to n, and then it prints n. So we have n equals 10. This is the global scope. And then we call add 1 with n. It's going to add 1 to 10 and then print it, which is going to give us 11. And then we're going to print n. What do you think n is going to be here, given what I talked about in terms of scope? This one is not going to change. So it's going to be 10. And if you don't believe me, we're given the exact same code here, and all we have to do is just run it to prove it. So I'm going to click submit. And let's just look at the output. We got 11 first and then 10. And again, if this is confusing, take a look at the description down here. It should make a bit more sense of why exactly that's happening. So let's learn even more about scope because it's a very, very important concept and it's also kind of difficult to understand. So let's look at this code here. We have a function declare variable. it doesn't return anything. All it does is declare a variable inside function only. It's assigned to 10, and then it returns. So it doesn't really do anything. We call the function, it didn't do anything, and then we call print on this variable, and it's going to cause a name error. It says this variable was never defined, but we did define it in the function, and once again, this is a consequence of scope in Python. This variable is only usable within the function. It's not usable within the outer scope outside of the function, aka the global scope. But when we try to do this code down here, n equals 10, and we don't pass a parameter into this function, we don't declare a variable in this function, we try to print n, which is only defined out here, this does not throw an error. It does not cause an error, and we call the function, and it actually prints the value 10. This is, again, a consequence of scope. It has to do with global scope versus local scope. Let me explain that visually. This entire scope, remember, is the global scope, and then we have the function scope. Suppose this function declares a variable, like we called it inside function only, but let's say the variable is called x, right? We set x equal to 10, and then we don't do anything, and then the function is finished. And then we try to call print out here, print x. It's not going to work because the global scope can't access a variable inside of a function scope after it's done. It can't do that. This is not allowed. But this function is just a subset, like the scope of this function is just a subset of the global scope. So if we had a variable x equals 10 here, and there's no x defined here, if there was an x11 here, of course we would use that, but it's not. So now we try to print x inside of this function, print x. It doesn't know where to find it, so it's going to look at the global scope and see there is an x out there. Go ahead and use that one and print it. So this is allowed. So this kind of explains why those two pieces of code worked the way that they did. Kind of try to think about it visually if it's confusing for you. So knowing all of that, let's just briefly review the differences between global and local scope. Variables declared outside of any function or other scope are considered part of the global scope. They can be accessed from anywhere in the program, including other functions. The local scope, though, is a bit more specific. A variable that was declared inside of a function, whether it's a parameter or it was explicitly declared inside of that function, it's part of that local scope to that function. It's only usable in that function. The local variables are created when the function is called, and they're destroyed when the function is finished executing. So you can't access them, obviously, when the function is finished. Now, knowing all of that, we have a challenge. There's a bug on the code in the right. If we try to run it, we'll see a name error, but we want it to print 100 and then 100. Let's take a look at the code. I'm going to run it just for fun. Let's see. Yep, we do indeed get a name error. We're calling print on num, but the number is not defined. So what's going on there? We have n equals 100. We have our function, which takes in a parameter and then prints it, and then we call print local number with n, which is 100. So this should probably print 100. I'm just taking a note for myself, prints 100. And then here we call print with num. Well, num is only usable in the scope of this function. We have n outside of the function, so we're not actually trying to print num, we're trying to print n, or you could just replace this with 100. I'm going to do n. Now, this should also print 100. Num should not be accessible outside of this function, so that's why we were getting an error. So now running it, we see we get 100 and 100 in the output. Python allows you to have default arguments for a function. So let's look at this code block. We have a function called greet, and it takes a parameter that is called name, but there's an equal sign after it, and then it's equal to a string called world. So let's look when we call greet, then without passing in a parameter, well, normally we'd expect it to throw an error, because if there's a parameter, we should pass in an argument for that parameter, but this time we don't. And right now it prints hello world. If we pass in Bob, it prints hello Bob. So why did it print world the first time? That's because name has a default value of world. If we don't pass in an argument for this parameter, it's going to by default be the string world. So it's going to print hello world. If we do pass in a string, it's going to be assigned to that string. So this is a default argument. We can have multiple variables actually. So for the multiple parameters, we can have greeting and then like name, and the default value for each of these is going to be hello and then world. So we don't have to specify both of these if we don't want to. We can also have just one of them be a default value. So the first one doesn't have a default value. That one is required. We have to pass in a parameter or an argument for that. The second one is not required. It has a default value of world. The third way is not valid. This is an invalid way of doing it. If the first one is optional, as you see, then the second one must be also optional. We can't have the first one be optional and then the second one be required, because how would we even call this function? Like in this case, what would we do? We'd say, okay, call greet, don't pass anything in for the first one and then pass something in for the second one. This syntax is very strange, and that's why this version is not allowed. If you're going to have default values, they have to go at the end of the parameter list. You don't really have to memorize this. It's not something that's going to come up super often, but it is worth knowing. Our challenge is, in the code editor, we want to update this function so that the second parameter has a default value of this string exclamation mark. So right now, if we try to run this code, we're going to get an error because we're missing one required argument, punctuation. That's kind of a clue. We called it the first time, it worked, but the second time on line 5, so let's go to line 5 here, we didn't pass in the second parameter. So we should pass something in here, or we should make this optional. So that's what I'm going to do. I'm going to make it optional. I'm going to make this have a default value of exclamation mark. And now it should work, and it does. So we're good to go here. So now let's learn about comparison. So this is going to be kind of a precursor to what we learn about next, conditional statements, but the idea is that we can compare values. For example, we have x and y, 3 and 5 respectively, and we compare them not with a single equal sign because we know that's reserved for assignment, but we compare them with double equal sign. So x equal to y. Like we're asking a question with double equal sign. Is x equal to y? So the result is either going to be true or false. In this case, 3 is not equal to 5, so the result is false. This is one example of a comparison. There are several others. So we do not equal with exclamation mark equal sign. So we're then asking, these two are not equal to each other. We can compare less than with, like, these are kind of similar to math, like less than with this and then greater than with this. And we do less than or equal with the caret equal, and we do greater than or equal with that. And so our challenge is basically to implement the operators up above. So we're going to get a very clear look at how these work. Starting with the first one, check equal, we kind of don't even need to read the description here because I think the functions are pretty self-descriptive. So here, check if these are equal. We want to know is x equal to y, and then we want to return the result. So we can do result equal x equal to y. So this will either be true or false. It'll be assigned to this, and then we return that. So that's one way to do it. A more concise way, though, is just to return the result of this. So return x is equal to y, and the result is going to be true or false. That's the easiest one. Now let's check if they're not equal. Is these two parameters not equal? Let's return x not equal to y. Again, it's going to be a Boolean. Now let's check less than. So this one might not be super clear, but we're going to be checking is x less than y. So we could have been doing the opposite, is y less than x, but in this case we're checking is x less than y. So we're going to return x less than y. So the result of that will either be true or false, and then we'll check is x greater than y, is x greater than y, and then the last two are a bit more interesting, is x less than or equal to y. So return x less than or equal to y, and the opposite is x greater than or equal to y. So there's a bunch of test cases here, quite a lot of them actually. I'll skip a lot of the simple ones that you'll kind of be able to determine on your own, but the last two are pretty interesting. 3 is less than or equal to 3. Do you think that's going to be true, or do you think that's going to be false? Well, less than or equal. So they're allowed to be equal to each other. So of course that's going to be true. Is 4 less than or equal to 3? Well, not to me. 4 is greater than 3, so that's going to be false. And then these, 3 is greater than or equal to 3. That's also true. If they're equal, it is true because they're allowed to be equal. And is 2 greater than or equal to 3? That's false. 2 is not greater than or equal to 3. Let's just confirm. In the output, you can see we do get the expected result. There's a lot going on, so I tried to add some text. So if you get any of these wrong, pay attention to what your result was compared to the expected result. Now let's finally get into some pretty interesting code, some conditional statements starting with if statements. If we want to run some piece of code based on some condition, we can do that with an if statement. Conceptually, it's pretty simple. So if we have, let's say, an account balance, which is negative 100, and then we check, is the account balance less than 0? Because if it is, we want to print some text. We want to say your account is overdrawn. You have like a negative balance. That's not good. So with this print statement will only execute if this condition is true. In this case, it is, so it's going to execute. Now, this print statement is outside of the if statement. And we know that because it's not indented. So similar to functions, this code belongs to this conditional statement, which is followed by a colon, only if it's indented. So this will always be printed regardless of whether this condition was true or false. It's possible, though, to have conditional statements inside of functions as well. So this kind of gets into how we want to indent our code. And the idea is that any code that's indented once will belong to this function. Now, if we want code to belong to the conditional statement, it needs to be indented relative to the conditional statement. So you can see this is indented once and twice. So that means this print statement belongs to this condition. So our challenge is going to be simple. We're given a function here, is balance low. If the balance is less than or equal to 100, it should print warning low balance. Otherwise, it doesn't print anything. Let's check. If, that's how an if statement starts, the balance is less than or equal to 100. So we do add that equal sign, then colon. And if that's true, let's print exactly warning, colon, low balance, period. And if it's not, then we don't do anything. So that's, we don't really have to put anything for that. So let's run this code. It should print low balance twice because it was called with 99 and then 100 and 101. This one won't print anything. So it looks like I actually did have the wrong output. And I think that's because mine it's kind of subtle, but mine had a capital B, but we expected a lowercase b. I probably should have just copy and pasted this on the left, but it's a good error to have. There's a lot of errors like this in programming where you're just kind of off by one character. So here we corrected that, and now we get the correct output. So now let's go to the next lesson. Unlike functions, in Python, if statements do not create a new scope. That means that any variables that are defined inside of an if statement are actually accessible outside of the if statement. This is different. If you're coming from Java or C++, this is different from those languages, so it's worth knowing. We have here an if statement. The condition is true, so this if statement is always going to execute. And then we create a variable, message is equal to hello. And then we try to print that message, and it works perfectly fine because a conditional statement does not create its own scope. So here, we can also use conditional statements to update variables that are outside of that conditional statement. So balance is declared up above, it's in the global scope, and then we execute this if statement. If balance is less than a 0, which it is, it's going to be set to 0. So this will evaluate, this will execute, and then down here, balance will be 0. There's only one balance. We don't have multiple copies of balance, and it was assigned to 0, so then we print 0. Again, if statements have the same scope as wherever they are defined. So if it's in the global scope, it will share that scope. If it's a part of a function, it'll have the same scope as the function. So this is an example of that. We have a function, is balance low? We check, is the balance less than or equal to 100? If it is, assign this to this string, and then print the string. When we call this function once with 50, it's going to print warning low balance. But when then we here try to print message, well, message was defined in this function. It was technically defined in the if statement, but either way, that variable belongs to the function. Therefore, it's not accessible outside of the function. So this line here will cause an error. This is nothing really new. It's just that functions have different scope than global. So if statements don't really change any of that. Now we are going to, in the code editor, implement a function called payBill. It's going to take two parameters, the balance and the bill. The balance is the account balance and bill is the amount of money that needs to be paid. If the balance is greater than or equal to the bill, so let's just start coding before we even read all of that, which sometimes isn't a good idea, but in this case, if balance is greater than or equal to the bill, then we want to do something. What do we want to do? The function should return the new balance after subtracting the bill from the balance. So it should return, let's call it new balance is equal to balance minus the bill. And then we want to return that, return new balance. Otherwise, the function should return the balance without making any changes to it. So down here, maybe we can return the original balance. This gets a little bit into what return does. So if we want to ignore that for now, another way of writing this code is before the if statement, we could also have a variable called new balance, which originally is set to the original balance. And then down here, we could also return that new balance. So now there's two cases. Either this if statement is not going to execute, in which case we return the original balance. If it does execute, we could actually get rid of this return statement. We'll update the new balance and then return it. And in that case, it will have subtracted the bill from the balance. I'm going to go ahead and run this, and you can see we get the expected output. You may or may not already know that when we return, we stop the execution of a function. We will talk about that more in a bit. Now let's get into if-else statements, because it's actually common to want to run either one block of code or the other block of code. And we can do that with an if-else statement. So here, look at the code without an else statement. We have balance is 100. If it's less than 0, print account is overdrawn. If it's greater than or equal to 0, account is in good standing. So only one of these is going to execute, right? Because if a balance is less than 0, that's the opposite of saying the balance is greater than or equal to 0. It's guaranteed that one of these is going to execute, and only one of these is going to execute. But it's possible to rewrite this code, which is slightly more readable. We can say balance is equal to 100. If the balance is less than 0, then print this. Otherwise, print the account is in good standing. So again, it's guaranteed that only one of these is going to execute, and exactly one of them. Either the first one executes or the second one executes. Else means only execute this if the other one did not execute. So this was false. Balance is not less than 0, therefore execute the code inside the else statement. Again, you can see the code is indented, therefore it implies it belongs to this block. And now, like I promised, what does the return statement mean? The good thing about conditional statements is that they can allow us to have multiple return statements within a single function, but only one of those return statements is ever going to execute. Take a look at this code here. We have a function called getMax. If A is greater than B, A is larger than B, so we want to return the maximum of these two integers, therefore return A. If that's not true, then return B, because either both of them are equal or B is greater than A, in which case we want to return B regardless. So the thing about this is that obviously we learned only one of these blocks is going to execute, but also when a return statement executes, it stops the function. Even if we had some code outside of this if-else statement, it would never execute because either this is going to return or this is going to return, and then the function will immediately stop. That's just a very important thing to know about functions because that comes up quite a lot. Knowing all of this, let's implement the function getMin. It's going to return the minimum of the two parameters, which are integers. So we want to also return an integer. If they're equal, it doesn't really matter which one we return because they're both the minimum, right? So let's implement it. It's going to be pretty similar to the max function that we had. So if A is less than B, return A, return the smaller value. Else, return B, because otherwise they're equal or B is smaller. I'll prove to you that this works, so let's just run this. This does work. Alternatively, we could have put an equal sign here. That would have worked the same. If A is less than or equal to B, it's still technically the minimum, so that works as well. Also, we could do this. We could get rid of the else statement actually, and here, either this will execute, in which case we found the minimum and returned it. Otherwise, we're going to return this. It's going to stop the execution and return regardless, so this also works. There's multiple ways to write the same code. Generally, we prefer to make it as readable as possible, so the else statement is fine, but all of these are pretty simple to understand, so it doesn't matter which way you write it, in my opinion. There is yet another variation of a conditional statement. It's called the else-if statement. And in Python, it's defined with this keyword. I think it's kind of weird, but it's elif. That stands for else-if. And this allows us to actually check multiple conditions in order. Suppose we have something like this. The balance is 1,000. First, we check, is the balance negative? It's not, so this one is skipped. Then we check, is the balance 0? It's not, so we skip this as well. Else if is kind of like an else block. It only executes if the prior statement did not execute, but else if has a condition. That's where the if comes from. So this will only execute if this is true and the previous one did not execute. So this one is also skipped though. Third one is the balance less than 1,000 or 100. Nope. So this is also skipped. Lastly, we have an else block. This one only executes if all the previous ones did not execute. So this one is true in this case because these ones didn't execute. So this is what we will print. In a chain like this with if, else if, and else, only one of the conditions is ever going to execute. That's very important to know. Even if multiple of these conditions were true, as soon as it finds one that's true, it's going to execute it and then stop checking the rest of them. For example, if the balance was -10, it would have printed this one, and then the other ones would not have been checked, and the other ones as well. So if the balance was 0, it would have executed this and not the other ones. Knowing all of that, our challenge is using if, else if, and else, implement the function called checkRange. If the number is less than 0, return this string, negative. If the number is 0, return the string 0. If the number is greater than 0 and less than 10, return this string. And lastly, if the number is greater than or equal to 10, return this string. So we're going to do those in order with an if-else chain. We're going to say, first off, if the parameter number is less than 0, return the string negative. Otherwise, else if the number is equal to 0, num equal to 0, return the string 0. Otherwise, else if the number is greater than 0, so num is greater than 0, and num is less than 10, we're going to return this. Return positive single digit. Lastly, the number is greater than or equal to 10. So I guess we could also put an else if here. We'd say else if number is greater than or equal to 10, return positive multi-digit. That's the string we want to return. So you can see some of the test cases down below, but let's go ahead and run this, and we get the correct output. Now, I didn't have an else block here, but technically this last part of the code could have been an else block. It's equivalent, because if the number is not negative, it's not 0, and it's not a single digit number, then it has to be a multi-digit number, right? That's logic, right? It has to be a positive multi-digit number. It has to be greater than 10. Otherwise, one of these three would have executed. They're mutually exclusive. So this could have been an else statement if we really wanted it to be. That's technically a little bit more readable. And here you can see that works just the same. And in a way, I actually got a little bit ahead of myself by using this condition here. I actually used a logical operator in a condition, and we could have rewritten this as well, because if we know that the number is not negative and the number is not 0, do we really have to check if the number is greater than 0? If it's not 0 and it's not negative, that's kind of implied, right? Like that's just math. So we could actually get rid of this as well and just check the number is less than 10. And that will work the exact same. So that also works. Now let's look at logic conditions, kind of what I was going over right now. We can use logical operators in a conditional statement. We know that a condition like this one, balance is greater than 0 and the balance is less than 0. This is going to evaluate to true or false. And we use true or false to execute conditional blocks. So in this case, 500 is definitely greater than 0 and less than 1,000. So this will execute. So we can use or, and not operators in a conditional statement. Looking at this challenge, we want to implement the discount applies function. It takes in the age of somebody, it's an integer, and returns true or false. So we should return true if the age is less than 18 or the age is greater than or equal to 65. Otherwise, it should return false. So just like that, I'm going to say if age is less than 18 or age is greater than or equal to 65, the equal is very important, we're going to return true. A discount applies. It's maybe a senior discount or, a young person discount. Otherwise, we were going to return false. We could do it like this, or we could just put this outside of the condition. Either one will work. I'm going to run this, and we get the expected output. Now, there is this interesting concept in Python and some other languages. It's called Truthy and Falsy. It's actually possible to use non-Boolean values to execute conditional statements. For example, we have a string, message, it's empty. We can actually do if message. This is not going to throw an error. Python is going to ask, is the string non-empty? If it's non-empty, then this condition evaluates to true. Well, I guess the justification is below. We'll get into that. But this time the string is empty, so it's not going to execute. Then we assign the string to a non-empty string. It's hello world, but it doesn't really matter what it is. It's non-empty. Therefore, this is going to evaluate to true, and this string will be printed. So this is called Truthy and Falsy. Non-Boolean data types can be converted to Boolean values in a Boolean context. That's kind of a fancy way of saying that like a conditional block is a Boolean context, right? Like the condition is either true or false. Therefore, a data type that's not a Boolean is going to be converted to true or false in that conditional statement. So an example of falsy values is, first of all, the value false itself that evaluates to false in a conditional block. None, the absence of a value, is also falsy. It's going to be false if we try to use it in a conditional statement. 0, whether it's an integer or a float, is also considered false. An empty string is considered false. An empty list in Python is considered false. And empty collections of other types, which we'll learn about later, are also considered false. Truthy values are basically, the Boolean value true itself, as you might guess. Any integer that's not 0, any float, any decimal value that's not 0.0, any string that's not empty, and any collection, any list or other collection that has at least one element. So they're kind of opposites of each other, right? If a value is falsy, then the opposite of that is going to be truthy. Can you kind of guess what this code is going to do if we have x equal to 10? Do you think x is truthy in this context? Yes, it is, right? It's not 0, so this is going to be printed. That's equivalent to saying x is not equal to 0. So if you prefer to be more explicit, it's okay to do that. Just check x is not equal to 0 and then execute the conditional block. The only reason I'm teaching you about this is because it's very, very common. It's a Pythonic way of writing code. It's very likely you're going to see code that looks like this. I don't want you to get confused. So if you prefer to write out your code like this to be more explicit, that's perfectly fine, but you're definitely going to see code that looks like this at some point. You can learn a bit more about Boolean contexts down below here if you want to. There are several others, but we're not going to get into that right now. Let's implement the function isTruthy. Given a value, which could be of multiple types, I guess, we want to return if the value is truthy, and otherwise return that it's not truthy. So if it's truthy, we're returning this string. If it's not, we return this string. And the parameter can be of any type. So let's get into this. As you might guess, we can check if this value is truthy just by using it in a Boolean context. The simple one that we know of is an if statement. So if value, let's return truthy. Otherwise, let's return falsy. We could have put that in an else statement or not. I'm going to choose not to do that. Now we're going to see 0. Do you think that's going to be truthy? Like all these values, let's just run it to find out. But it's just going to match what we saw earlier. 0 is falsy, 10 is truthy, 0.0 is false, 10.0 is true, empty string is false, non-empty string is true. This is one way to write the solution, and we are finished here. Suppose we had some piece of code that we wanted to execute multiple times. Like we really, really love Python and we want the world to know 5 times. We could obviously print it 5 times. We could even store this string in a variable and reuse it, but we'd still need to have this code written 5 times. Even if it's a part of a function, we'd have to call that function 5 times. So we can get around this with something called a loop. Specifically, this time we're going to be looking at while loops. Take a look at this code. We have a variable, we're calling it I, and it's set to 0, and we check while I is less than 5, execute this code. So it's kind of like an if statement. I is definitely less than 5. There is a condition here that's going to be true or false. So this is definitely a Boolean context. And we have a colon, and then the code that belongs to the while loop is indented. And then we print this, and then we increment I by 1. We add 1 to I. This is very important, because if this line did not exist, I is less than 5. Go ahead and print it. And then the loop actually will execute again. It's not an if statement which only executes once. This will execute multiple times. And If we didn't increment I, it would just go infinitely long. That's an error we want to avoid, so we increment I. So then I is still less than 5, and it'll keep going. It'll go exactly 5 times because I will be 0, 1, 2, 3, 4. Once it's equal to 5, the condition is false, and it won't execute anymore. It'll stop. Now, it's worth knowing that loops also don't define their own scope, just like conditional statements. But now for our challenge. We want to print, I know how to use while loops exactly 12 times. There's many ways to do this with a while loop, but we're going to kind of follow the semantics here. I'm going to set I equal to 0 while I is less than 12. We're going to print that string. I'm just going to copy and paste it so that we don't run into any issues. So there, I know how to use while loops. I'm going to run this just to show you what the error we're going to have is. It gives us an error saying the file was too long because we printed, look at this. We kept printing to the point where we just couldn't print anymore. The output was too much. We only wanted it 12 times, but we did it an infinite amount of times to the point that our program crashed. So let's fix this by incrementing I by 1 each time. So this will print exactly 12 times. Another way to have written it would be I is set to 1, and while I is less than 13. That'll still print exactly 12 times from 1 to 12. Once it's equal to 13, it'll stop. So just to prove it to you, this indeed also works. We can use while loops to print digits, not just printing like text. For example, let's consider this challenge to us. In the code editor, can we use a while loop to print the digits from 0 to 9 in that order, including 0 and 9? So our loop should execute 10 times. And just to give you the syntax, this is the overall structure of what a loop looks like. Let's use that to solve this problem. So I'm going to have a variable. I'm going to call it n. I guess you could call it I, whatever you want. I'm going to initially set it to 0. So we want to print n 10 times. And we want to stop once it equals 10. So we could do this multiple ways. We could say while n is less than or equal to 9, go ahead and print it. Let's indent this and then increment it by 1. So it'll go from 0 up until 9. It'll execute true when it's 9. When it's 10, it'll stop. So run this and it works. Alternatively, we could have said while this is less than 10, because as soon as the condition is false, the loop will stop. This will work the exact same. And there you go. Now another challenge. In the code editor, can you use a loop to print multiples of 10? From 10 up until 90, including 90, and in that order. So what do you think we should do now? I mean, the overall structure was something like this. While n is less than or equal to 9, let's print 9 and then increment it by 1. This was from 0 to 9, but we want multiples of 10. So obviously we want to start at 10. So n is equal to 10. And the condition, we don't want to stop at 9. We want to stop at 90. So let's change this to 90. This is not going to do exactly what we want. Let's print it just to see what we get and what the expected output is. We're going from 10 up until 90, but we're incrementing by 1. That's not what we want. We want multiples of 10. So to fix this, we're going to increment n by 10, not by 1. So this will give us multiples of 10, and we get the exact output that we're looking for. Now let's look at another way of writing loops. These are called for loops. These are going to be defined with the keyword for. So just to look at it really quickly, with this loop, we print numbers from 0 to 9 inclusive. And this is done with a while loop by having a variable outside of the loop and incrementing it by 1 each time. This loop is doing the exact same thing up above. The only thing is the variable was defined here on this line right after the keyword for. And then we use the keyword in this range. Range is a function. When we pass in 10 into this function, it creates a range from 0 to 9 inclusive. not including 10. It goes from 0 up until 9, this number minus 1. So then it'll print this number, and we don't increment it inside of the loop because this is going through the sequence from 0 up until 9. So obviously this is a shorter way of writing the same code. This is more explicit. This is less explicit. So you might prefer the first way of writing it, but this way is generally more common. So you can read over this to review the exact syntax of the loop, but the best way to really have it sink in is to actually type it out. So that's what we're going to do. We're going to write a for loop to print the numbers from 0 through 12, including 12, in that order. We could do it with a while loop, but let's try it with a for loop. So just following the syntax here, for I in range up until 13, right? If we put 12 here, what's this going to do? And then we print I. We know we don't have to increment I in this. This is going to go from 0 through 11. It's not going to include 12, right? So if I run this, it's going to go from 0 to 11. As you can see here, stopping at 11, and the output that we wanted was stopping at 12. So if that's what we want, let's go ahead and add 13. So now it's going to print 0 through 12, which is what we wanted. I know this is a little bit confusing because we have an extra, like 13 is not going to be printed. That's when we're stopping. So now we have the correct output here. But for loops can actually be even more interesting than that. It would be pretty limiting for a for loop if we had to start at 0 every single time, but we actually don't need to do that. The range function can take 2 arguments. Let's take a look at that. So we have a while loop here, starting at 2, going up until 5. So this loop will print 2, 3, and 4. It'll stop when we get to 5, so it won't print 5. The for loop down here will do exactly the same thing. It's going to start I at 2. It's going to stop once we reach 5, and it's not going to print 5. It's not going to execute that time. So it'll go from 2, 3 to 4, and it'll increment by 1 each time. So these 2 loops are equivalent. This is the for loop. It's obviously shorter. So our challenge now is to use a for loop to print the numbers from 10 to 20 in that order, including 20. So just following the syntax here, we want to start at 10. So I'm going to say for I in range, 10 as the first parameter. If I try 20 as the second parameter and then print I, this is not going to work. This is going to go from 10 to 19. It's not going to print 20. You can run it just to prove it to yourself. It didn't print 20. It stopped at 19. So if we want to print 20, that's the expected output. Let's change this to 21. Now I run it, and this time does print 20. We get accepted. Now, again, it would be kind of limiting if we had to increment by 1 every single time. In for loops, we actually don't need to do that. So look at the code below. This is a while loop. I starts at 0. While I is less than 10, print it, and this time add 2 to it. So this loop will print 0, 2, 4, 6, and 8. Once it gets to 10, it'll stop the loop. It's not going to print 10 because 10 is not less than 10. It'll stop at that point. This for loop down here does the exact same thing. Remember, the first parameter into range is the starting point. I is going to start at 0, just like up here. I is going to stop once it reaches 10 and not include 10. The third parameter, though, here, the first time we're using it, is the step. That's what we're going to be incrementing by. When we don't supply a third parameter, the step is going to be 1 by default. But when we do supply it, it could be anything we want it to be. In this case, it's 2. So this loop will go print 0, then 2, then 4, then 6, and then 8. Once it's 10, it'll stop. So both those loops are equivalent. Now let's create a for loop, which is going to print all multiples of 10 from 0 up until 100, including 100 in that order. Let's just have the syntax here to the left just to make sure we get this right. So for I in range, we want to start at 0. We want to go up until 100. initially I can put 100 here, but we know it's not going to include 100, even though that's what we want to print. But the step is important. The step is going to be 10 because we want multiples of 10. So here we'll go ahead and print I. Now, if we run this, of course, we're not going to include 10. We're missing that one. So you could put 110 here. That will actually work, right? So this does work. But you could actually put any number that is greater than 100 and less than or equal to 110. And I think we'll learn about that in the next lesson. So we can also use for loops to actually iterate in reverse order. And this is a little bit confusing. So consider this while loop to start off with. We start at 10. We want to check is I greater than 0. And then we want to print it. And then we're actually going to decrement because we want to go in reverse order. So we'll go 10, then 9, then 8, and all the way up until 1. And once I is equal to 0, it'll stop. It's not going to print 0. So it'll print from 10 to 1 in reverse order. This for loop is going to do something similar. It's going to start at 10 and stop at 0, but not include 0. And it's going to decrement by 1 each time. So the step here is negative. By default, it would be positive 1 if we supplied 1, but this time it's not. It's negative 1. And we're going to print I each time. It's going to do the exact same thing, print from 10 through 1. Knowing that, our challenge is to use a for loop to print the numbers from 20 through 10, including 10, in reverse order. Let's do that. So for I in range starting at 20, stopping at 10, and negative 1 is the step, we're going to print I. We actually do want to include 10. This will stop at 10, but we want to print 10. So I'm just going to take the 1 minus that, which is 9. This is the solution. This is one way to get the solution with a for loop. And as you can see here, we match the output. There is definitely a more readable way to do this because this is kind of confusing to read even for people who are familiar with Python. So I want to show you a slightly more readable way to do this. And here you can see that, a shortcut for reversing. Take a look at this here. For I in range 10, remember that that's going to go from 0 up until 9. If we take that range and pass it into a function that's called reversed, it's going to do 0 through 9 in reverse order. So it will go from 9 down to 0. It just takes a range and goes through it in reverse order. So let's use this to our advantage. We want the numbers 20 through 10. Well, let's consider 10 through 20. We can do that pretty easily like this. This will be 10 through 20, but we want to include 20, so we put 21. So this will give us 10 through 20, but it'll do it in ascending order. We want to go in reverse order, so let's wrap this entire thing around the reversed function, and it'll do 20 through 10 now in like reverse order. So printing this, whoops, I had a typo. I had said reverse. The name matters. There's a D at the end of it, so let me add that D and try this again. And now you can see we got the exact same result that we wanted. Many people prefer doing it this way. Now, to look at nested loops, a very, very important concept. They come up very often. Suppose we have a set of integers 1, 2, 3. We want to get all possible pairs of this set. A pair is 2 values. So we want like this pair, 1, 2. This pair, 2, 3. And in this case, the order of the pairs does matter. So we consider 2, 1 to be a different pair than 1, 2. So those pairs would look something like this. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, etc., etc. And you can see this pair is different from this one because the order is different. So it's kind of like a 3 by 3 table, right? We have 3 values. We take like the square of that and we get a 3 by 3 table. We get 9 values in the output. This can actually be accomplished pretty easily with nested loops. And the code is very, very simple. Take a look at this loop. We have one loop on the outside. For I in range from 1 to 4, not including 4. So we're going to get 1, 2, 3. Now we have a second loop. We have a loop inside of a loop, right? So the indentation does matter here. We have this loop j in range from 1 to 4, not including 4. So once again, 1, 2, 3. And every time we're printing the pair of numbers. This is called a nested loop, and this is what it's going to do. First, I is going to be 1. Then it's going to execute the code inside. So j is going to run from 1, 2, 3, and then stop at 4. So you can see I is printed first and then j. The output is going to be this. I is 1, j is 1. I is 1, j is 2. I is 1, j is 3. So that's one iteration of the outer loop. Next, this loop stops, and then we go back here to the outer loop. I is now going to be 2, and then j is going to be 1, it's going to be 2, it's going to be 3. Those are going to be printed. You can see that down here, 2, 1, 2, 2, 2, 3. And then finally, the third time, I is 3, and then this loop is going to go through 1, 2, 3, while I stays as 3. So this way, we get those pairs that we wanted. In total, how many times is this print going to run? Exactly 9 times, because the outer loop runs 3 times. The inner loop runs 3 times for like every time the outer loop runs. So it's 3 times 3. We get 9 total executions, 9 total prints. So knowing this, let's print all pairs of numbers from this set, from 3, 4, 5, where the order of each pair does matter. So it's going to be kind of the same as this. So we're going to have one loop. I'm going to call for I in range from 3 to 5, but we want to include 5. So we're going to set this to 6. 6 is not included. And then for j in range, 3 to 6 again. And then we're just going to print those numbers, print I and j. So let's go ahead and run this. And we got the output that we expected. So now to finish off loops, let's look at control flow. This is kind of optional. You don't need to know it, but it's worth knowing because it can make code more readable, and it's common to see stuff like this out in the wild. So there are a few keywords that can control the execution of a loop from inside of the loop. There's one called break. When this line of code executes, the loop will immediately stop. There's another keyword called continue. When this executes, it will skip the remaining code on that iteration of the loop and then move to the next iteration. I'll show you what I mean in a second. But the third one is the most simple, pass. It literally doesn't do anything, and this keyword actually can be used outside of a loop. The idea is that we can't have an empty loop. Like you see over here, the loop doesn't do anything. We're not allowed to have an empty loop, so pass acts as a placeholder. It basically does nothing, but we won't get an error. If we try to remove this, we will get an error. We don't want that, so we leave the word pass. Same thing with an if statement. We can't have an empty if statement or an empty function, so the keyword pass will fix that. It will not give us an error if we have pass. So here's an example. None of this code does anything, but it won't throw an error either. Now, the other keywords are a bit more useful. This code here, we have a loop. It's going from 1 through 8. So if I is equal to 3, it's going to continue. If I is equal to 6, it's going to break. Otherwise, it's going to print I. Now, the output of this loop is going to look like this. It's not going to print 1, 2, 3 up until 7. It's going to skip 3. Why did it skip 3? Well, because if I is equal to 3, we execute continue. It stops everything here. It won't even execute this code down here. It'll stop and it'll go to the next cycle of the loop, the next iteration. So if I was 3, well, stop and then go to I equals 4. And then continue from there. So 4 is printed, 5 is printed, but 6 isn't printed, and 7 isn't printed either. Why is that? Well, when I is equal to 6, we break out of the loop. We stop the loop altogether. Not just this iteration, but we stop the entire loop. So as soon as I equals 6, stop the loop, don't print 6, and don't print anything after that, so 7 isn't printed either. So this is an example of these two keywords, these two control flow statements being used. Now, there's nothing we have to do in this challenge. We're just going to submit the code to prove that it doesn't do anything, and also there's no error caused. So just skimming through the code, you can see we use pass a few times. Here we have a loop that's going to print I, but we have a break statement before that, so the loop is actually not going to do anything. It's going to immediately stop. Same thing down here. We have a continue statement before the print, so it's always going to skip every iteration of the loop. Lastly, down here, we have an actual print statement. This part is going to execute. So let's run this, and you can see we get the expected output. So this is kind of an advanced technique. You don't have to be super good at it as a beginner, but it can make your code more readable when you learn how to use it correctly. So now let's talk a lot more about strings, because they're a pretty important data type, and we're actually going to start with the length function. So if we're given a string like this, for example, NeetCode, we can actually call a pretty important built-in function. It's len, that's what it's typed as, but it stands for length. So here in this example, you can see we're given the string. We can call len on it, length, and the return value of that is going to be 8 in this case, because the string has 8 characters. So let's practice with this a bit. We're told to implement the getLongerWord function. So we're given 2 words in this function, word 1 and word 2. They're both strings. We want to return which one of them is longer. Now, an edge case, of course, is what if they both have the same length? Well, in that case, there is some details for us. If the words have the same length, return the first word. In this case, let's check exactly that. How do we figure out which word is longer? Probably by getting the length of it, right? So let's say length of word 1. If it's greater than the length of word 2, obviously we return word 1. If else, then we would return word 2, but we haven't handled the case where they're equal. Well, I guess we have. If they're equal, we're going to end up returning word 2 in this case, because the else is going to execute. That's not what we want. If it's greater than or equal, we want to return word 1. Otherwise, we return word 2. So the equal is very important here. And of course, we don't need the else. This will work, but we didn't need the else. We could have put this outside of the if statement, and this would have worked just the same, as you can see here. That's that for just getting the length. But there is some more that we can do with strings. We know that strings are a sequence of characters. If we want to access individual characters from a given string, we can actually do that like this. And it looks a little bit strange at first because we have a string hello. It has 5 characters in it. We can access the first character by having square brackets after the string name and then putting a 0 inside of it. That gives us the first character. We can get the second character by square brackets and a 1. We get E. And then the third and the fourth and the fifth. So the last character actually goes at index 4, even though the length of the string is 5. So that's strange. That's definitely different than you might expect. Why doesn't it start at 1? Well, that's just how programming kind of is. You can think of the index as like the offset from the beginning. So 0 is an offset of 0. We're at the beginning and we don't offset at all. But 1 is adding 1 to the beginning, so an offset of 1. That's one way to think about it. But here, just for visual purposes, first character is at index 0, second is at 1, 2, 3, and 4. So 5, even though that's the length of the string, is an invalid index. And by the way, this is called zero-based indexing. It's pretty common in most programming languages. So again, like I said, if we try to access index 5, we actually get an index error. We're trying to access an index that doesn't exist in this string. So be very careful about that. The length of the string is 5, but we cannot access the length as an index. We'll get a chance to practice this with a few functions. So we're going to implement print the first character. We're just given a word, a string. We're going to assume it's not an empty, and we're going to print the first character. Pretty easy to do. I'm just going to do that like this. We know the first character is not at index 1. It's at index 0. To get the second character, we're going to print index 1 because it's 0-based indexing. The second character will be at index 1. So lastly, though, this one's more interesting. Print the last character in a word. Well, that's going to require some information. We kind of need to know what the length of the string is. So we get to practice taking the length of a string once again. Remember, if we have a word of length 5, the last character is going to be at index 4. If we had a word of length 4, the last index is going to be at index 3. So we can get the last index like this. Take the length of the word and subtract 1. And then we print the word, the character at the last index, just like this. So of course we could have put this here. We don't need a separate variable for this, but just kind of for readability, that's what I did. So let's run this just to confirm. And you can see it indeed gives us the expected output. One thing we kind of assumed was that we were going to at least have a first character and a second character, and that assumption was okay because that information is provided to us. So now let's get into looping. Now you're seeing kind of a lot of the concepts we already learned coming up once again. So looping through a string is very interesting. If we wanted to go through every character in this string, you might already know how we can do that, because take a look at this. If we get the length of a string, this one has a length of 13. That means the indexes for all the characters are going to be from 0 through 12. So if we create a loop like this for I in range, and this is going to be the value 13, we'll be able to access the index of every single character in the string. Now you kind of see why Python makes the range function like that. If we pass 13 here into the range function, we're going to get values from 0 through 12. That's going to be useful. That's intentional by Python. It does that on purpose. With this, we'll be able to print every single character in order, and each character will be printed separately, so it will go on a separate line. Now let's look at the challenge. We're going to implement this function, print string characters. We're given a string, it takes a parameter, and we want to print each character of the string separately. So kind of just implementing what we just saw earlier. So let's see if we can do it from memory. For I in range length of the string, this will give us all the valid indexes of the string, and we just want to print a character. We can access the character like this, my string at index I, and then to print it, it's just this simple, just pass it into the print function. Now every character from this string and this string should be printed on a separate line. Let's just confirm. Yep, hello world, good job, exclamation mark. So perfect. Now, there's actually a shorthand way. So taking a look at this code, we have a string here. We iterate for I in the range of the length of the string. We print I and the character at index I in the same print statement. So this in Python will actually print both of those values with a space in between them. If we have multiple parameters into the print function, we will separate them with a comma, and they will be printed with a space in between them. So we get the index and the corresponding character at that index. But it's possible we actually don't even need the index. If the only thing we cared about was the character itself and just looping through the characters in order, there is a shorter way to do it in Python, just like this. For character in my string, we don't even need the range function. I think this might be the first time we're seeing the for loop without the range function. So this will iterate through every character in the string and then print that character. The variable name in this case is char. It could have been something else. It could have just been the character C. It could have been I if we wanted. It doesn't matter. We need the keyword here. We need a variable here, a keyword in, and then the string itself. So that's kind of the syntax. Now, knowing this, we're going to implement a function that's going to print the characters from the two parameters that are given to us. So it's going to print all the characters from word 1 and then all the characters from word 2. And let's try to do it using the shorthand method. So here on the right, we're going to do this. For character, for C in word 1, print that character. And then as soon as we're done with that, go through every character in word 2 and then print that character. It's very simple. We're not returning anything. We just want to print all the characters from this word and this word. We don't need to take the length of either word in order to accomplish this. So we should be able to get this output with each character on a separate line, and that's exactly what we get. Now we have string concatenation. We actually learned a little bit about this earlier. I think it's so simple that it was fine to introduce it earlier, but now let's get a more concrete look at what we're doing. Concatenation is just the process of combining two or more strings into a single one. Python allows us to do this with the plus operator. Some languages allow you to do it with plus. Sometimes you need a function to do it. But keep in mind that when we use the plus operator, we're actually creating a new string combining these two strings. So here, pretty simple, we have hello, comma, space, and then world, exclamation mark. We add these two and then print the result. We're going to get what you'd expect, hello world. Now, we are given this function to implement. We get two parameters, string 1, string 2, and we want to return a new string that is the concatenation of both of them. But if the length of the string after concatenating them is greater than 10, we are told to return this string instead, too long. For example, if we concatenate these two strings, we're going to return good job because the length is not greater than 10. But if we concatenate these two strings, it's obviously greater than 10. I think we have something like 14, 15 characters, something like that. In that case, we want to return this special string. As you might be able to guess, we want to obviously concatenate these strings. I'm going to call it S3, I guess. S1 plus S2. Now, if the length of S3 is greater than 10, let's instead return that special string, too long, exclamation mark. Otherwise, let's return the new string S3. That means it was less than or equal to length 10. So this is the logic. Let's give it a go. And here you can see we did get the expected output. Great. Now let's get into a pretty interesting and useful topic called slicing. It actually applies to more than just strings, kind of like what we've talked about earlier as well. We're going to learn all about that later on, so I won't get into that just yet. But if we have a string like this one, and we only wanted to access a portion of that string, we can accomplish this with slicing. It allows us to get a substring from a string by specifying a range of the indices. So for example here, we have the start index as 1, the ending index as 5. So the syntax is this. We have the string, we specify the start, and then a colon, and then the end. So we're not accessing a single character, we're accessing a range of characters from this index up until this one, but not including that one. So what do I mean? Well, index 1 is this character, the E. Index 2 is this, index 3 is this, index 4 is this, and index 5 is this one. So by specifying 1 through 5 as the range, we start at 1 and we go up until 5, but not including 5. Therefore, this range will only give us 4 characters at index 1, 2, 3, and 4. So the output that it prints is going to be LO, no comma. With that in mind, we are told to implement this function, get substring. We're given an input string, as I'll kind of show on the right, but we're given an input string and we're given a start index, which is an integer, and an ending index, which is also an integer. It takes a string and 2 integers, and we want to return the substring from the starting index to the ending index, but not including the ending index. So at first you might think it's very simple. All you do is take return input string from start to end, right? That's it. But there's a little bit of a catch. So down here, it's possible that the ending index is an invalid one. It might not be valid. It could be out of bounds. So if that's the case, we want to return an empty string. So in that case, we'd return an empty string here. Now, they tell us we can assume that start will always be a valid index and that end is always going to be greater than or equal to start, but it's possible that end might not be in bounds. So given that, how do we know if the ending index is out of bounds? Well, the last index would be the length of the input string minus 1. This is the last valid index, length minus 1. So if the ending integer given to us is greater than the last valid index, so if end is greater than length minus 1, then we know it's invalid. When it's invalid, we want to do this. We want to return the empty string. So I'm going to put that inside the if statement. Now, if this doesn't execute, we know that the ending index is valid. We can assume that. So in that case, we execute this code. So let's give this a go. Actually, it turns out that we had the wrong answer, and I think this is a very easy mistake to make, so I'm actually kind of glad that I made it, so now I get a chance to actually explain why this is actually not quite correct. So, for example, suppose we have the string hello, right? We have hello like this. The index of each of these characters is going to be 0, 1, 2, 3, and 4. Suppose the range that we're given, so we're given start is equal to 0, and we're given end is equal to 4. So if we were to try to return that substring, we're going to start here at h, and we're going to end here at index 4 at O. But we know that the second index, the ending, is non-inclusive. So this would give us this substring. I didn't mean to make it a swear word. Sorry, that's a coincidence. But it would give us this substring. If we wanted the entire string, we'd actually pass in an ending index of 5. So remember, the last index is non-inclusive. This will actually not give us an index out of bounds error, partially because it will start here and go up until index 4, not index 5. It'll give us every character from 0 through 4. So this is actually valid. So what I'm getting at here is that this calculation that we had, if end is greater than length minus 1, which is the last index, we actually don't want to check if it's greater than length minus 1. We want to check if it's greater than the length, because that is the last valid index we could have for the ending range. 5 in this example is valid for the last. Anything greater than 5, though, doesn't make sense. So here we will change this to that. So we'll get rid of all these notes, and now we're going to change it to this, and now it should work. And yep, there you go, it does. Now, there's a bit more to slicing than you might expect. So it's actually not necessary for us to pass in the start. So here we have a string, NeetCode, and we don't specify the starting index, but we have a colon, and then we specify the ending index. Kind of like with the range function when we have a for loop, it will imply that we're starting at the beginning. So if we don't specify anything, we're starting at index 0, going up until index 3, which is going to be over here, but not including index 3. So this is the substring that we get, the first 3 characters. And so that's equivalent to if we specified the starting index as 0. Now, it's also not required for us to specify the ending index. And as you might be able to guess, if we do that, we're going to be starting here at index 4. I think that is here at C, and we'll be going up until the end of the string. So we'll be getting this part of the string code. That's the same as if we were to do this, 4:8. So now the last lesson might make a bit more sense, because this is index 0, 1, 2, 3, 4, 5, 6, 7. So the last index is at index 7, but we pass 8 here. So we're going up from 4 to the end of the string, right? Including the 7th index, but not including the 8th index. So this would also give us code. These two are equivalent. If we don't specify either of them, if we just have a colon, that's the same as just getting the entire string itself. The only thing is this would create a temporary copy of that string. Knowing that, our challenge here is to print the first n characters of a given string s, and n is going to be a parameter, and we're going to return the first n characters. So we're not printing it, actually, we're just returning it. So it looks like we can assume that the length of s is going to be greater than or equal to n. So we don't have to worry about like an index out of bounds error, I guess. So how do we get the first n characters from a string? Well, if you were to look carefully at this example, if we had a :3, we obviously get the first 3 characters, and that pattern is going to hold. If we had a :4, we'd get the first 4 characters, not including index 4. So here we can say return s from the beginning up until index n. That's going to give us the first n characters. The second one's going to be more interesting, actually, the last n characters. The fact that these are challenging, believe me, is a good thing. You wouldn't want me to give you the easy, trivial problems, and then when you go out to actually write some real code, you don't know what to do. So if these are challenging for you, that's fine. That's a good thing. Make sure that you kind of understand what's going on here. Given a string s, we want the last n characters from the string, and we can assume that the length of s is going to be greater than or equal to n. This is kind of challenging. It's not quite what you'd expect. It's not going to be this. It's not going to be return s starting at n : because this will start us at index n, but we don't necessarily know that there's going to be n characters in the remaining portion of the string. There's no guarantee about that. So there is a little hint over here that's going to help us. If we want the last character from a string s, we would start at length -1, right? That would be the starting point because we have 1 character left in the string from that point. If we want the last 2 characters, we do length -2. That would be the starting index. So if we want n characters, our index should be this. Index equal length of s minus n. That's the starting index, because then we guarantee that there are exactly n characters left in the string starting from this position. So now let's give this a go, and you will see that we do get the expected output. Now let's look at reversing a string. There's a pretty easy way to do this with slicing. The idea is that just like with a range function, how we can have a step, we can specify the beginning, the end, and we can have a step. We can actually do the same thing with slicing. So we have 2 colons this time, and we don't put anything before the first colon or before the second colon, but then we put a -1, and this -1 is the step. So this means we want the entire string, because we didn't put anything for the start and the end, and we want a step of -1. So we want the entire string in reverse order. So the output of printing this is going to be the string in reverse order. And this might make a bit more sense to you if we look at this example. Here we have start at index 1, end at index 4, so here through here, but not including index 4, so we'll get this, L, and a step of 1. This time we don't specify the step because by default the step is 1. We could have done it, we could have had a second colon and then 1, it would have been the same as this. But if we change the step to a -1, then we get the same substring but in reverse order. So the step is the third value after both colons. Knowing that, let's implement this function, reverse string. We're given an input string and we just want to return the reversed version of that string. We want the entire string, so all we do here is return input string and : -1. Just reverse the entire string. Let's give that a go, and you can see it works as expected. Now, it's very important to know that strings in Python are immutable, and this is usually actually true for most languages, but that means we cannot modify an existing string. So look here on the left, we're given a string, I will never change. If we try to access the character at index 0 and try to reassign it from I to X, it's not going to work. This is going to cause an error because strings are immutable. It's going to give us a type error, I think. So we cannot change individual characters. We can only create new strings. Whenever we're slicing a string, that's also true. We're not ever modifying the underlying string. We're only creating a new string with only the portion that we sliced. If we did want to create a new string only replacing one character, we'd have to build that string ourselves from scratch. For example, delete the character, like the second character, which is at index 1, which is this space character. we can get all the characters before that index like this, :1, it'll stop at 1 and not include that character. And then we can start at index 2 from this W and get every character after that. So we'll get this and this string, and then we'll concatenate those together to get the new string. So that would basically be us deleting this character from this string. Knowing that, let's implement a function, remove the 4th character from a given word, and then return the new string. And we can assume that the length of the string is always going to be greater than 4, so we don't have to worry about any index out of bounds error. So how are we going to do that? It's going to be similar to what we have here. So let's get the first part, which is, I'm just going to call that. We're going to get everything before index 4. So we'll take the string, get a colon, everything up until index 4, but not including index 4. To get the second part, I'm going to do word starting not at index 4, at index 5, because this is inclusive. So we're skipping index 4. We're starting at index 5 and going up until the end of the string. Then we concatenate these together, first part plus second part, add them together and return the result. So for this example, we should return, let's see, actually removes the 4th character. So I think I messed up. So we're removing the 4th character, but not the character at index 4. So actually I did kind of mess up. So before we even run it, good thing I caught that. So here we're going to actually stop at index 3 because the 4th character is at index 3. And then we're going to start at index 4, skipping the character at index 3. And then those are the parts. And then we're going to add those together here and then return the result. So for the first example, we should return or delete this T. So it should print NeetCode. And in the second example, we should delete this character and we'll get hello with just a single L. Let's see if that is what we get. And it looks like it is. So we've passed this one. Now for a little bit about string formatting. We saw that we can concatenate strings together, but this can be kind of annoying if we have a lot of strings to concatenate. There is a more elegant solution in Python, and it uses the format method. So here, let's make this bigger. So we have a string Alice, and we have another variable actually, which is an integer. If we want to add these together into a string in this format, we can do so. So this is the string, hello, comma, with these curly braces. You are this many years old, again, some curly braces. So the curly braces serve as placeholders. And from this string, we call dot format on the string. So this function is being called on the string itself. And we pass in a couple of variables, the name, which is Alice, and the age, which is 25. So the first parameter will fill in the first placeholder. The second parameter, the second argument, will fill in the second placeholder. So the string that we get is hello Alice, you are 25 years old. So that's what's going to be assigned to the message over here and then printed. This is one way of formatting strings. We can be a bit more specific if we wanted to. We can put a number inside of each placeholder. So 0 would tell us that this first parameter is going to go in this spot. The second parameter is going to go in this spot if you wanted to do it that way. Otherwise, it'll just fill them in order that they appear. So this one would go here, this one would go here. I prefer doing it this way, but if for some reason you wanted to have them in a particular order, you can do that as well. A third way that some people prefer is called f-string. So you don't even need to call the dot format function, and you can do so with f. So starting with f, so this is a special syntax. We can start the string with f, then have the quotation marks, and inside of that string, we can have curly braces and directly use the variable name in the curly braces. So obviously, Alice would go here. The age, which is 25, would go here. So this is even more concise, I think, than the previous ones. So knowing these three ways of doing it, let's implement a function called sayGoodbye. That is going to return a string in this format. Goodbye, name, see you again at hour o'clock. So the name is going to go here. The hour is going to go here. Let's return a string that does that, and we can do it multiple ways. I'm going to use f strings because I think it's the most readable. So return f quotation marks. And now I'm just going to actually copy this string just so we don't have to type it out, but you could type it if you want to. And now I'm going to replace the name with, well, I'm going to wrap it in some curly braces because it does match the parameter name already. And then here, our, it also matches the parameter name. So I'm going to wrap it in a couple curly braces. This is the entire code. Let's run it. And you can see we get what we would expect. So there's a lot we learned about strings, and there's a lot more to learn. There's a lot more built-in functions, but these are kind of the core ones that I would think you should definitely have a little bit of experience with. You don't have to memorize every detail, but just kind of knowing that we can do a lot with strings is pretty important. So now let's finally talk about lists. So these are an interesting data type. And the good news is that they have a lot of overlap with strings, but they do have a few key differences that we will be going over. To begin with, a list is just a collection of items that are in a specific order. So at first it sounds like a string, but item is a general term. So here you can see we have a list of numbers, not just characters, but numbers. We can get the length of a list just like we do with a string by calling the len function. And in this case, we have 3 items, so the output is going to be 3. We can index a list just like we can index a string. So we get the first element with index 0, second with index 1, third with index 2. So far, it's similar to a list. Now down here, you can see we have a list with these numbers. A difference between lists and strings are that lists actually are mutable. We can modify the values in a list. So this is a very key difference. So index 0 initially was 1. We reassign it to 10, and then we print it, and it works perfectly fine. The output we get is 10. And obviously, lists can store not just numbers, but they can store other things. They can store strings. So in the first index, we have a string I. In the second index, we have a string M. So this is a list of strings. We are printing each word as we index this list. And we can even mix and match types in a single list. So we can have 1, hello, 3.14, and true, though it's not recommended because it can become kind of unpredictable what data type is in each position. So generally this is not recommended, but it is possible in Python. So we have a challenge. We're given a list like this. We want to print the following things, each on a separate line. So first we want to print the second element in the list. So recognize that the second element is going to be at index 1. So that's what we do. Then we want to print the third element. That's going to be at index 2. So just like this. Third, we want to print the first element in the list. That's going to be at index 0. And then we want to print the length of the list, just like this. The name of the list is my list. So then we print it. So those are the 4 things. This is a pretty nice and easy warm-up question. Nothing super crazy here. And we get the correct output. This was a list of numbers. Now, to get a bit more interesting, there are some operations that we can do on a list. Now, first, what would happen when we try to use a list in a Boolean context? Well, here we see we get the length of the list, check if it's greater than 0. That means the list is not empty, of course. Otherwise, we assume the list is empty. If the length is 0, it's probably an empty list, right? That's pretty safe to assume. Down here, though, we do the same exact thing, except a little bit differently. We check if my list. So using a list in a Boolean context will be true if the list is non-empty. If it's empty, then it evaluates to false, and we would execute the else statement. So basically, this code is equivalent to this code. This is what happens when we use a list in a Boolean context. If we want to know if a list contains any particular element, we can do that with the in operator. We say if 2 is in my list, then this is obviously going to evaluate to true, and we're going to print 2 is in the list. Otherwise, we know that 2 is not in the list, and we would print 2 is not in the list. So this is going to evaluate to a true or false value, and then we're going to use that to execute one of these conditions. So in this case, 2 belonged to the list. We can also do the opposite if we want to, and that's done in a pretty readable way in Python. We don't put the not before the condition. We say if for not in my list. If 4 is not in the list, this will be true and this will execute. If it is in the list, then the else block will execute. So this is just a way of determining if a list contains a particular element or not. In the code editor, we're going to implement a couple functions. Check if the list is empty. If it's empty, return true, otherwise return false. So let's start with that one. It's pretty easy. If the list is empty, so if a length of my list, which is the parameter, is equal to 0, let's return true. Otherwise, let's return false. The second function, check element in list. We're given a list and we're given a specific element. We want to return true if the list contains that element and false if it doesn't. So let's just check if element in my list return true. Otherwise, return false. So this isn't super crazy, just kind of applying what we learned here. Let's execute this. And you can see we get the expected output. There is a way to actually make this a bit more concise if we wanted to. If the element is in the list, this itself will be true. And that's what we would want to return, true. If the element was not in the list, this itself would be false, and that's what we would want to return. So can't we just do this? Return the result of this expression, element in list. Return true or false, right? So this is the exact same as what I showed earlier. Similar here, if the length is equal to 0, we want to return true, and this will evaluate to true in that case. If it's not equal to 0, it'll evaluate to false, and that's what we would want to return, false. So let's just return the result of this expression, this Boolean expression. If length is equal to 0, return true. Otherwise, return false. Just return the result of the expression. This is a nice, concise way to do it, and we get the exact same output. Now, looping through a list is very similar to looping through a string. So here you can see that we can, one way, do this by getting the length of a list and then iterating for I in the range of that list. It'll give us index 0 through index 4, and we'll be able to print each element. We can also do it similarly with a string as this, element in my list. It'll go through every element, and this way we don't really get access to the index of each element, but maybe we don't need the index of each element, so this would be sufficient. If you don't need the index, usually it's preferred to do it this way. So our challenge this time is to count x. We're given a list of nums, and we're given an integer x for this function. We want to count how many times does x appear in this input list, and we want to return the result of how many times it appears in that list. Just to quickly mention here, we have a type annotation here where we have nums and it's a list of integers. That's the type annotation. And we have an import statement up here. The only thing this is doing is allowing us to add the type annotation, because if I get rid of this, then we get an error. We're not allowed to use this type annotation. So that's just how Python is. So you don't have to, know too much about this for now. But we're given this list of numbers. We want to count how many times does this appear. It probably makes sense to loop over every element in nums. I'm going to say for n in nums, and we want to check if n is equal to x. For every time this occurs, we should probably increment the count by 1. I'm going to call it result. You could call it count. You could call it whatever you want. This is counting how many times x occurs, and that's what we want to return after we loop over the entire input. So the only thing left for us to do is actually count how many times it occurs. So in this if statement, if we find an occurrence of x, let's increment the result variable by 1. Let's just quickly look at the examples. 5, how many times is it going to appear? It's going to appear twice here. 5 appears 0 times in this. 7 appears, looks like 3 times in there. So we should get 2, 0, 3. Let's see if that's the expected output. 2, 0, 3. Yep, and we got it. So we're good to go here. There are some pretty neat functions that we can call on a list in Python, some pretty nice built-in functions. These are kind of the important ones. These work on integer lists specifically. So we have a list of numbers here. We can call a built-in function called sum. It's going to compute the sum of all elements in this list, which is 15. We also have min. It's going to calculate the minimum of all elements in this list. In this case, it's 1. We have another function max. It's going to get the max of all of them. In this case, it's 5. So pretty self-explanatory. We are actually going to implement these functions from scratch ourselves. We're given 3 functions: get sum, which is, as you can imagine, we're going to compute the sum of elements in this list. We're going to get minimum, get the minimum from this list, and get max, get the maximum element from that list. We can assume that every list is going to have at least one element. And also, if we want a challenge, let's try to do it without using the built-in functions. Let's try to loop over the elements and manually keep track of the sum, the minimum, and the maximum. Also recall that since these are built-in functions, let's try not to use variable names that conflict with these built-in functions. It's generally not wise to do that. So let's try to code this up now. So to get the sum, this is probably the easiest one. Let's just call it total, or you could call it total sum. I'm initially going to set it to 0, and then I'm going to go through every value in the input. To total, I'm going to add every value in the input, and then I'm going to return it. So this is just going to sum every value and then return the result. Next, we have get minimum. And the variable name I'm going to use in this case is current minimum. And if we try to assign it to 0 to start off with, this is actually going to cause a bug. Let me just fill out the rest of the function so I can explain it to you. Obviously, we're going to go through every element in the input. If n is less than what our current minimum is, let's reassign it. Now we found a smaller element. Let's set current minimum equal to n. This seems like it works, but consider the example down here. Get minimum from these 4 elements. If we initialize current minimum as 0, none of these elements are smaller than 0. So the result we end up returning is 0. But 0 doesn't even show up in the input. So this is kind of a bug. What initial value can we possibly set this element to? Well, the good news is we don't actually have to come up with that. There are ways to set this to like an infinitely large number, which would make sense. But the best and most simple solution to this is just initially set this as the first element from nums. So either the first element in nums is going to be the smallest value in the input. So on this example, it's 7. That's not the smallest value in the input, but that's okay because we iterate over every element in nums. We'll go to 7, we'll go to 3, and we'll find that 3 is smaller than 7. So we'll execute the if statement, and current minimum will be assigned to 3. If there's a smaller element, it'll be assigned to that as well, but 3 is the smallest in this case, so that's what we end up returning. So it doesn't really matter what we set current minimum to as long as it's a value that's actually present in the input array. And as you can guess, get max is going to be very, very similar. I'm going to call it current max. I'm going to initialize it to just arbitrarily the first element in the list. And this is what we're going to try to return, current maximum. And then we're going to go through every number in nums. If n is greater than our current maximum, then assign current max equal to n. We're trying to get the largest value, and this is how we do that. So now we've completed these functions. Let's go ahead and run this, and we got the expected result. Now, there's a lot more that we can do on a list. We don't just want to sometimes change individual elements and reassign them in a list. We can also add elements to the end of a list. Lists are mutable in Python. We can modify an existing list. So we can add to the end of a list with the append function. This is not a separate function. This function is called on the list itself. We call it with .append 4. So we had a list initially, 1, 2, 3. We append 4. It goes at the end of the list like this. So a couple clarifying things. When we call a function on a variable itself, it's called a method. This is more related to object-oriented programming, which we're not going to cover in this course, but we will be covering in the object-oriented programming course of Python. So it's not super important to know. It's just if you're wondering why do sometimes we call functions with a period at the end of a variable versus why do we sometimes call like the function and then pass in the variable, this is kind of the reason why. A list is considered an object in Python. A string is also considered an object, but again, we're not getting into that for now. But also notice that the length of the list initially was 3. After adding an element, now we have 4 elements. So the length also increased. So we are given this function to implement. We're given a list and a bunch of elements in a second list. It should take every element from the second list and add it to the end of the first list and then return the new list. Let's do exactly that. We're not just appending one element to this list, we're going to append multiple elements. So how do we get those elements? Probably with a loop. Let's say for n, or you could call it element or whatever you want. For n in elements, let's take this element and append it to my list. My list dot append this element. And after we've done that, let's return the new list, my list. Technically, we are actually modifying this list. By doing this, we are modifying this list. We're not creating a new one. So that's a subtle point, but it is kind of important. The output here you can see is what you would expect. Not only can we add elements to the end of a list, we can also remove elements from the end of a list. So given a list like this, 1, 2, 3, we call dot pop on it. It will remove the last element in the list, which was 3. So we're left with 1, 2. By default, pop is going to remove the last element, but we could remove an element from a specific index if we wanted to. So here we have 1, 2, 3. We call dot pop 0. This does not remove the element 0. It removes the element at index 0. So that's very important to know. The element at index 0 is 1. So it's going to remove it. And the result is going to be 2, 3. And then we're going to call dot pop again. So what's the element at index 0 now? Well, it looks like this is the array we have. This is the list that we have. And the element at index 0 is 2. So removing that leaves us with a list of a single element, which is 3. So knowing that, the challenge is remove from my list the element at this index. And that's all it's going to do. And then it's going to return the result. So let's just get started with that here. We can go ahead and just call my list.pop at this index and then return the result, return my list. So that's pretty easy to do. Now the second one here is pop n from my list. So what this means is pop the last n elements from the list and return the modified result. So if n is 1, we just pop from the list once. If n is 2, we pop from the list twice, etc., etc. So for this, it's probably best to use a loop. So let's do something like this. While n is greater than 0, then call mylist.pop, so pop, and then decrement n by 1. So if n is 2, for example, this loop will execute twice. We'll pop from the list twice. And let's not forget to return the resulting list, my list. That's all we want to do, and just some clarifying notes here. We can always assume that the index that we're removing from is going to be valid, and we can assume that the list that we're popping from is going to have at least n elements. Now let's go ahead and run this, and we get the expected result. Now let's try to find elements in a list, and thankfully there's a built-in function to do that as well. So we know that we can check if a list contains a specific element with the in operator. That's pretty easy. But what if we want the index of that element? So for example, we're given a list like this, 1, 2, 3, 4, 5, 3. We call .index 3. This will tell us the index of the element 3. It occurs at index 2, so that's going to be the output. But there's actually 2 copies of 3 in this list. Why did it give us index 2, and why didn't it give us index 5? Because that's the index that this 3 occurs at. Well, this function is always going to give us the first occurrence of 3. The first one from left to right is here. It's at index 2, so that's the return value that we get. It's possible that we call .index and the element doesn't even exist. In that case, we would get an error, a value error. So keep that in mind. Given this, we want to implement this function, find index. We're given a list of numbers and a target number. We want to know what index does this number occur at. It should return the first occurrence of the target number in the list, so similar to the index function. And we can assume that the target will always be present in the list. Obviously, the easiest way to implement this function would be to do something like this. Return nums.index of the target. And since we can assume that it's always going to be present, we never get an error. So running this code, you see we get the expected result. But for a challenge, let's see if we can implement it ourselves without calling the built-in index function. Let's try to do that. We want to loop over every number in nums. And if we find it, if n is equal to the target, we want to return the index. We know for sure that we will find the number. The target definitely exists. But the way I wrote this loop, how do we get the index? Well, I didn't do it correctly. We used a for loop without the index. So this is an occurrence where we actually need the index. So I'm going to rewrite this loop. I'm going to say for I in range of the length of nums. And then to get an individual element at this index, I'm going to say n is equal to the nums at this index. So now we still have n down here, but if this is true, we're not returning n, we're returning the index, we're returning I. And so we went through the numbers from left to right, so we will find the first occurrence and then return its index. So this will also work. Let's run it, and you can see it works. Now, the good news is that we can also slice lists, and slicing them is exactly the same as slicing a string. So we have colon, we have the starting index and the ending index. So index 1 to index 3, but not including index 3. So we get 2, 3, but not including this one. So this is the subarray that we would get. Same thing here. Starting from the beginning, going up until index 3, but not including index 3, so we get that 1, 2, 3. From here, starting at index 2, going up until the end of the list, we will get 3, 4, 5. And here, going from the beginning to the end in reverse order. This is the negative step. We'll get the entire list in reverse order. That's exactly what we have here. So pretty similar to with a string. But there's one thing about slicing or indexing that we didn't talk about. What if we use a negative index? This is actually not invalid. It's not going to give us an error because Python allows negative indexes. It can sometimes be helpful because if we want to access the last element in a list, we just pass in -1. It'll give us the last element. If we want the second to last element, we pass in -2. The third to last element at index -3. So this works like this. It's kind of equivalent to doing it like this. If we wanted the last element without using negative indexes, we would have to take the length -1. That would give us the last index here, and it would give us the last element. And the second to last element would be length -2. Third to last element would be length -3. So these are equivalent to what we have up above. Obviously, up above is a bit more concise, but it's also kind of confusing if you're new to negative indexes. It's very common, though, to see code that looks like this with Python. So now our challenge is to get the last 3 elements in this given list. It should return a list containing the last 3 elements, and we can assume that the length of the list will always be at least 3. So how do we get the last 3 elements? Well, if we wanted the last element, we would do something like this. My list, starting from the length of my list, -1. This is the last index in the input. We can do length -3, and this is the third to last element, and then we can put a colon after it, and then this will give us from the third to last element up until the ending of the list. And we can return this, and it'll work just like you would expect. It'll give us the last 3 elements from each of those lists. But there is an easier way, as we kind of saw with negative indexing. We can do the same exact thing. We can get the third to last element with -3 as the starting index, and then go up until the end of that list. So this is equivalent to doing it like this. So both of those work the exact same. Lastly, we're going to briefly talk about tuples. The good thing about tuples is that they are very, very similar to lists, except these are immutable. So kind of like strings, these are immutable. We cannot change a tuple. Tuples are declared with your rounded parentheses, not square brackets. Lists are square brackets. Tuples are round parentheses, but these are still ordered sequence of elements. They could be numbers, they could be strings, they could be whatever type. So we can print it, and this is the output we would get. We can index a tuple. We can get individual elements from a tuple just like this, just like with a string, just like with a list. We can also slice a tuple, because when we slice, we're not modifying the existing tuple, we're creating a new tuple with that slice. So the slicing rules are the exact same, but again, we can't modify a tuple. If we try to change the element at index 0, we get an error just like we would with a string. So we can't do that. And if we can't modify a tuple, you can imagine we can't call append on it, and we definitely can't call pop on it either, since these would modify the tuple. But we can call sum, max, and min on a tuple, because these don't modify the tuple. They just calculate some value based on the values in the tuple. Tuples are pretty common to store related data, especially if you don't want to modify that data. We are given a function to implement create pair. We're given a string name and an integer age. We want to combine these two into a tuple and return it. The tuple should contain the name first and the age second. So just like with lists, we can combine data types in a tuple. We can have multiple data types in a single tuple, and you can see this is the type hint for a tuple, and we needed an import for that. So this tells us we're returning a tuple where the first value is a string, the second value is an integer. So here we're gonna return a tuple. Tuples are with round parentheses, and we're gonna put the name first, the age second, and then return this. So let's go ahead and run that, and we get the expected result. Sets are another really important data type in Python. They're pretty similar to lists, but they have a few pretty key differences. One, sets are not ordered. So that means that you can add a bunch of elements to a set, but the order of those elements is not guaranteed. So if you were to try to iterate through the elements in that set, the order could be unpredictable. So don't rely on the order of elements within a set. Another important point is that sets can only contain unique elements. You cannot have duplicate elements in a set. So let's just briefly look over some code for a set. Here you can see that the set is declared with curly braces, not square brackets. That's how lists are declared, but a set has curly braces. We have 1, 2, 3, but again, the order of these elements is not necessarily guaranteed. So here, you print the set and you might get something like this, and we have the same set in, let's say, reverse order, and you might get something like this. So again, no guarantee about the order. So here we declare an empty set, and we actually do that with the keyword set and then a couple of parentheses. So we're calling a function here to create an empty set. We're not doing it with empty curly braces. And the reason for that is that empty curly braces actually create a different data type, which we'll be talking about pretty shortly. But here we first add 1 to the set, then we add 2 to the set, and then we try to add 1 again. That's not going to do anything. 1 already exists in the set. We cannot add duplicates. So our set will look something like this when we print it, just 1, 2. So now our challenge is, given a list of numbers, create a set from those numbers. So the idea is, the easiest way that we might know how to do it is just to go through every number in the list of numbers and then add it to a set. Well, first let's create an empty set. Let's just call it my set, and we'll create an empty one like this. And now to add to a set, we call the function not append. We do that with a list, but with a set, we do add, not append. So just be very careful about that. So now we're going to say my set, add this number. And then after that, we're going to return my set. So let's just run this, and it works as you would expect. There are a few more operations we can do on a set. So removing is pretty important, and we can remove based on a value. So we're given a set like this, we try to remove 2, and then we're left with a set like this. So 1, 3, 2 has been removed. If we try to remove a value that doesn't exist, we're going to get an error. So try to be careful about that. Now, how would we know that 4 doesn't exist in the set before we try to remove it? Well, there is a way, and I think we are going to cover that towards the end of this part. But just like with lists, we can iterate over a set. The order that we iterate over them is not necessarily guaranteed. So again, the order could be unpredictable, but we can still iterate over a set with a for loop similar to how we would with a list. We can also actually convert a list into a set very easily. So this would have been helpful to know for the last challenge, but we can just call set and then pass in a list and it'll convert it into a set. So if we had a list like this, it's going to turn into a set like this. And that's because the duplicates have been removed. A set cannot have duplicates. And if you're curious about why that is, I would check out the Data Structures and Algorithms for Beginners course, because these sets are implemented with hash sets under the hood. We can also check with a set if an element is contained in that set. So we have a set like this, cat, dog, mouse. We check, is this string in the set? It evaluates a true. Cat exists in the set. What about lion? Is it in the set? Nope, it doesn't show up. So this evaluates to false. So now our challenge is to implement a function, count the number of unique words in a given list. And it's possible that the list could be empty, in which case we would return 0. So how are we going to do this? Well, we didn't really learn yet how to take the length of a set, but we actually don't need to know that, because the easiest way to do this would just be to eliminate the duplicates. So we can do this just like this. We can convert the words into a set like this, word set, and pass in the list of words in here, and then I'm going to declare a variable, let's call it count. So initially it's going to be 0, and now we're going to loop over the word set. So I'm going to say W in word set, and I'm going to increment the count by 1. We don't even really use the word. So the word set will not have duplicates. So that's why I'm doing this. However many times we loop over is however many unique words are left over, and then we can return the count. So here we can return the count, and so this will solve the problem for us. And there actually is an easier way. We learned about the length function earlier. We can call length on a string, we can call it on a list, so why wouldn't we be able to call it on a set? We can actually do exactly that. So you can convert this list of words into a set and then just return the length of that word set. So that's another way of solving this. Now to just practice with some sets. So we're given a function called contains duplicate. This might look familiar to you if you're solving some LeetCode problems lately, but we're given a list of words and we want to return true if that list of words contains some duplicates. Otherwise, we want to return false. There's many different ways to solve this problem, so let's try to get creative. So does the list of words have any duplicates? Well, one way to solve this would be to create, let's say, a set, my set, and initially it's empty, and then let's go through every word in words. We check, is this word already been seen before? Well, I guess before we even do that, we want to take every word and add it to the set. So let's say my set.add this word. Before we add it though, we want to check, is this word already been seen before? Have we already added it to the set before? And if we have, then we have duplicates. So at that point, we know the result of this function is going to be true. So let's just return true in that case. Otherwise, we go through the rest of the words. And then if we never see a duplicate out here, we can return false. So this code will work, as you can see here, but there's a slightly easier and more elegant solution. Why not just take all the words and throw them into a set? Because that's going to remove all possible duplicates. So let's do something like this. So now we know that there's a duplicate if the length of the set is smaller than the length of the list. So we can check, is my set, the length of it, less than the length of words? If it is, we can return true. So in other words, we can just return the result of this expression. If it's less, then there are duplicates. If they're equal, then it's going to return false. So running this, you can see it also works. So now let's learn about one of the single most common data types in Python and one of the single most useful. They're called dictionaries, and they are used to store key value pairs. So the simplest way to think about it is in terms of a table. So we have a mapping from a key to a value. So in this case, the key is going to be a string, and in this row, it's Alice, and Alice maps to the value 25. Bob maps to the value 30, Charlie maps to the value 35. Pretty simple conceptually, right? You might be familiar already with maps or hash maps, and a dictionary in Python is pretty much just a map or a hash map. So that's another way of calling these. So you might hear them called maps or hash maps. It's kind of the same thing as a dictionary. So here is how we can declare a hash map in Python. Notice that it looks similar to a set. We still have curly braces and the values are separated by commas, but the thing itself, like each row in that table, is going to be this. It's going to be a pair, and the pair is separated by a colon. The part that's to the left of the colon is going to be the key. The value to the right of the colon is going to be the actual value. So, that can be thought of as like this visual representation. And down here, this is just another way of writing the exact same thing. This is just formatted on multiple lines. Maybe this is a bit more readable for you, so feel free to format it like this if you would like. Another way of creating a dictionary is like this. So now you see we have empty curly braces. Empty curly braces in Python are empty dictionaries. That's why we couldn't use that for an empty set. So this is an empty dictionary. And to insert a value into a dictionary is actually not going to be with a function like add or anything like that. The easiest way to do it is like this, to take square brackets and then put the key in those square brackets. So this time we have a string Alice. We're mapping that to the value 25. Bob is mapped to the value 30. Charlie is mapped to the value 35. So it's kind of like an array, except, this is not an index. This is kind of the key. Now our challenge is to implement two functions. One is create dict. So create a dictionary. Dict is short for dictionary. I'm not making that up. So we're going to take a name string and an age integer, and we're going to create a dictionary, an empty dictionary, mapping the name to the age and then returning the dictionary. So let's start with that because it sounds pretty simple. So create a dictionary. The easiest way, I guess, to do it is calling it something like this, mapping the name to the age. So we're taking the string, that's a name, mapping it to the age, separating them by a colon. And then we're going to return that. Obviously, another way of doing it would have been to create the my dictionary, make it empty, and then map the name to the age like this. So that's another way of doing it. You can do it however you'd like, but I'm going to leave it like this. So the next one is list to dictionary. So we're given a list of words and we want to convert it into a dictionary by mapping each string to its index in the list and then returning the resulting dictionary. So the mapping, the key is going to be the word, the value is going to be the index. You can think of it like this. This string might map to value 0. This would be value 1. This would be value 2. These are going to be the indexes. So let's do exactly that. How do we do it? Well, first we should iterate over the words. So one way to do that is like this. Remember, we're going to need the index of each word. So we want to kind of keep that. So I'm going to do it like this. I in range length of words. Now to get an individual word at index I, let's just do this. W is words at index I. Okay, now we have the word and we have the index. So let's create a dictionary up here. I'm going to make it empty first of all. And then I'm going to map my dictionary. I'm going to take the word and map it to the index. And I'm going to do that for every single word in here. And then I'm going to return it. So down here, I'm going to write return my dictionary. So now let's run this. And you can see it works as expected. Now, just like sets, dictionaries cannot contain duplicate keys. So think of a dictionary like this, A1, B2, C3. If we print A, we're going to get the value 1. So this is how we can access a value from a dictionary. We can read the value that belongs to this key. Now, if we try to assign that key to a new value like 4, and then we print it, we're going to get the value 4. It's going to overwrite this value. We don't have two keys with the key A. So it's overwriting that. We cannot have duplicate keys in a dictionary. Now, the values themselves can actually be of pretty much any type in a dictionary. So here you can see a dictionary where A maps to a list, and here you can see B maps to a set, and here you can see C maps to another dictionary here. So it's kind of hard to see, but here, C maps to a dictionary. We can have nested dictionaries. So that's kind of interesting. We won't get super into that, but just know that it is possible in Python. Now, even though the keys have to be unique in a dictionary, the values don't necessarily have to be unique. So A could map to 1, B could map to 1, and C could map to 1. They can all map to 1. That's perfectly fine. We can also check if a key exists in a dictionary by using the keyword in, just like we do with sets, just like we do with lists. Knowing all of that, let's implement the challenge. So we want to perform the following operations on the given dictionary. Print the dictionary itself. Okay, that's pretty easy. I'm going to start with that. So here, let's just print your dictionary. Next, we want to print the value of the key A. How do we get that? That's pretty easy. Your dictionary at key A. So this is going to give us some value, whatever it is, let's print it. So just like that. Third, print true or false depending on whether the key D is in the dictionary. So how do we know if the key D is in the dictionary? We'll just check, is D in your dictionary? And we want to print the result of that. So let's do this. Now, fourth, reassign the value of the key A to 4. So right now it's 10. Let's reassign it to 4. So this time we're not even printing anything. So this key is going to be mapped to 4 now. And now print the dictionary again. That's the last step. So let's go ahead and do that. Print your dictionary. Not super crazy stuff, just getting kind of familiar with dictionaries, but we can see that we get the expected result. Now we can use the length function just like we could previously to get the length of a dictionary. Now this specifically is going to give us the number of key value pairs, as you would expect. This dictionary has 3 key value pairs, so that's the result that we're going to get when we try to calculate the length of it. Just like with sets, the length itself isn't really going to help us loop over the dictionary. If we want to loop over the dictionary, the easiest way to do that is with the keyword in on the dictionary. So we create a variable here, we call it key. We could have called it anything we wanted to, but regardless of what we call it, it's always going to be the keys in the dictionary. So when we're looping over the dictionary like this, we're going to get all of the keys, A, B, C. And with the key itself, we can of course get the value. So with the dictionary, we could just say my dictionary with the key, and that'll give us the value. So we can still get both the key value pair by iterating over it like this. Now, there is a slightly more concise way to do it with the items function. We call .items on the dictionary itself, and then we try to loop over it. That will actually give us both the key and the value at the same time, and then we can print it. So it's kind of the same as what we did up above. It's just a bit more concise because we don't need this line. We can automatically get the value in a particular variable, but it's pretty optional. You don't really have to know this. It won't really save you that much time. Now, given this challenge, let's see what we got to do. Get the dictionary keys from a dictionary. So we're given a dictionary and we want to just get all of the keys from that dictionary and then return them in the form of a list. So the keys in this case are going to be a list of names. So let's start with that. So we're given this dictionary. We probably want to loop over it, right? We want to say for key, or we could call it name or whatever. I guess I'll call it name for name in age dict. And we want to take this name and add it to a list. I'm going to call that list the result. And then I'm going to say result.append this name. And we do that with every single key. Then we go ahead and return the list of keys. So great. Now let's do the second part. Get the dictionary values from a dictionary that looks kind of similar to the previous one. So this time, instead of getting the keys, we want to get the values. So it's going to be very similar to what we have here. I'll still write it out from scratch though. So here we're going to go over for every, let's say, name in age dict. And then we want the value. We want the age. So we can say age dict. Given the name, we should get the corresponding age. We also want to have a list here. Let's make it empty. And then to this list, we want to append not the name, but this time we want to append the age. And then after all of that, we can go ahead and return that list. So let's go ahead and run this, and you can see we get the expected result. One very common use case of a dictionary is to count the occurrences of elements in a list. So for example, we're given a list like this with a bunch of numbers. Some of them are repeating. We want to count the quantity of each element. So if we were to do that for this list, it would look like this. We have 3 occurrences of 1, 3 occurrences of 2, and 3 occurrences of 3. So let's implement a function that's going to do this. Well, similar to this, the function is actually going to count the characters in a given string and then return a dictionary which counts the occurrences of each character. Now, the only challenging part about this, well, it might be challenging in general, but an even more challenging part about this is going to be the fact that if we try to access a key that doesn't exist in a dictionary, it's going to give us an error. So we have to be able to handle this case, and I'm going to show you how we can do that. So let's first just start off looping over every character in this string. So we can do that like this for C, or for character in Word. We're going through every character. We want to have a dictionary. I'm going to call it count. It's going to initially be empty. We know this is what we're going to return, so I'm going to put that return statement down here. Now we just have to count the occurrences of every single character. How do we do that? Well, normally we'd say something like this. For the count of this character, increment it by 1. The easiest way to do that is kind of like this, right? Now, it's possible that the key, the character, hasn't been inserted into the dictionary just yet. So it's going to give us a key error because this is the same as writing it like this. It's the same as saying count of the character plus 1. So obviously, how can we access the count if we haven't even inserted the character yet? So before we can do this, let's check if the character is not in the dictionary. It's not there. Let's just initialize it to 0, for example. So now it's set to 0. So this way, we'll guarantee that we'll never get a key out of the dictionary error. We'll never get that type of error. And it'll always be set to 0. So either we'll set it to 1 here, or maybe the key already existed, and then this won't execute, and we'll just end up incrementing whatever value was already stored there. So let's go ahead and run this, and you can see we get the expected result. Another way of writing this code that might make more sense to you is something like this. Instead of having an if statement by itself, let's also have an else statement. This would mean that if a character doesn't already exist, and this is the first time we're seeing the character for this hash map, let's set it to 1. If it already exists, let's increment it with this code. So this might be a bit more simple if you're a beginner, so I just want to show you that this also works perfectly fine, as you can see. We can also remove pairs from a dictionary. We can remove them based on the key. So we can call the pop method something like this. We're given a dictionary that looks like this. We call .pop on this key. It'll remove this key value pair, as you would expect. Now, if we try to call pop on a key that doesn't exist, we're gonna get a key error. So keep that in mind. If you don't want to worry about handling the key error case, there actually is a built-in way to do that. So here we have a dictionary with keys A, B, C. We try to remove the key D, but we actually pass in a second parameter. We pass in 0. So what this is going to do is say, try to remove this key. If the key doesn't exist, just return 0 and don't throw an error. This time, even though the key doesn't exist, no error is going to occur. Now, another way of deleting from a dictionary is by using the delete keyword. So we have a key like this, we can delete that key with this keyword. Knowing that, let's try to take on the next challenge. We want to implement the remove keys function. We're going to be given a dictionary, and we're going to be given a list of keys. We want to remove all of these keys from the dictionary. Now, it's possible that some of those keys don't even exist in the dictionary. In that case, we want to ignore them. We don't want to throw an error. We don't want an error to occur. So there are different ways that we can handle this, and I'll try to show you a couple of them. So let's start by iterating over every key in the list of keys. So we want to remove the key from my dictionary. So first, let's just check that the key exists in the dictionary. We can do that like this: for a key in my dictionary. If it's in the dictionary, this will evaluate to true. In that case, we can remove it. We can say my dictionary.pop this key. After all that's done, we can go ahead and return the dictionary after removing all of those keys. Let's run this to make sure that it works. And you can see it does. Now, there is another way to do this without the if statement by using the second parameter of pop. So it'll try to remove this key, but if it doesn't exist, we don't want an error to occur. So we're just going to pass in a second parameter. In this case, I'm going to do 0. You could do 1. You could do 100 if you want. I'll just prove it to you. I'm going to do 100. This is going to be the return value from this function if the key doesn't exist. Nothing else is going to happen. Let me just run it, and you can see it works as you would expect. Another way of iterating over a dictionary is by using .values. If we only care about the values in a dictionary, we can skip the keys and do something like this. Take a dictionary like this, call .values on it, and iterate over that. So this will only print the values 1, 2, 3. It'll ignore the keys. So this is useful if you only wanted the values, but it's even more useful if you want to take the values from a dictionary and then convert them into a list, because we can say my dictionary.values and then call list on that, and then it'll convert 1, 2, 3 into a list that we have here in this variable. So knowing this, let's take on the last challenge in the dictionary section. Once again, let's implement get dictionary values from this dictionary. So it'll be a little bit easier for us now that we know what we know, because we're gonna take this dictionary, just get the values from it, convert them into a list, and then return that. So it's pretty easy to do. Age dictionary, we don't have to loop over it. We can just say age dictionary.values and then call list on this, and then we can return that. So I'm gonna go ahead and run this, and you can see it works as you'd expect. Now let's learn about reading input. We've spent a lot of time printing output to the console, but we can actually read input from the console as well. If you're running programs locally, you can actually type manually the input into the console, and then your program will read that input once the program is running. But to simulate it in this course, we're actually going to be reading some predefined standard input. So input can come from a stream called standard input. Again, this can be user data, like that user is typing in, or it can be predefined input that we are going to supply in this example and throughout the course. How we can do that in Python is actually pretty easy. We call the input function. So this is going to do a couple things. Input takes in this parameter, in this case, this argument, this string, enters some text. So this is going to be printed to the output, and then one line of input is going to be read, and then this function is going to return that line and then store it in this variable. And then we're just going to print that line. So that's what this code would do, whether you run it in this console here, like in this code editor, or if you ran it locally, it's going to do the same thing. It's going to read one line of input and then print it, and also print this part too. The interesting thing though is that this part is not going to be printed on a separate line. So this is going to be printed, as you can see down here, enter some text, and suppose the input was some text, then this would be printed on the same line. That's at least going to happen in our environment where the input is predefined. If you are typing out the input, then you might see it twice. But here, knowing all of this, let's now take on the current challenge. Read and print input. This function should read a single line of input from the console and print it to the console. the prompt that we should provide is going to be this, reading one line of text into a string. Let's just start with that. We know we can read a line of input like this, calling input and then passing in the string. They tell us that this is the string that we want to pass in. So I'm just going to copy and paste it. Whoops. And there we go. So now I've printed it. So what's the other thing that they want us to do? Okay, so this is going to be read into a variable. And then we want to print whatever line that we read. So let me just store this in a variable called line. And then here I'm going to print that line. And now we've created the function, and they also want us to call this function exactly twice. So I'm going to do exactly that, read and print input once, and then I'm going to copy that line and then write it twice. So now let's go ahead and run this to see what exactly happens. So this is the first time that the output is a bit more interesting. We actually have input here. So this is the hard-coded or predefined input that we are going to supply to your program. So here it's one line. This is the first line NeetCode provided you, and this is the second line NeetCode provided you. So the output of our program, though, was this. We called input twice, so it makes sense that we have reading one line of text into a string, and then we printed that line. This is the first line NeetCode provided you. And then we entered that prompt again, reading one line of text, and then we printed that line. This is the second line NeetCode provided you, and that's exactly the expected output. So this is definitely more interesting than just printing to the output. We're actually reading input this time. Now, one common thing to do with reading input is actually type conversions, because whenever we read input, we're always going to get a string. So let's learn about that. So first of all, here we can see that when we call input, we actually don't need to pass a string into this function. It's an optional parameter. If we don't pass a string in, nothing is going to be printed, but we're still going to read a single line and then store it in this variable, and then we're going to print that line. This is perfectly acceptable. Like I mentioned, whenever we read input using this function input, it's always going to be returned in the form of a string. But if we're expecting a different data type, like if we wanted somebody to enter their age, we're expecting it to be an integer. So we can get that input, and then we can call int on that input, on that string, and then convert it into an integer, and then it'll be stored in that variable as an integer if we wanted it to be. We could do the exact same thing with a float if we wanted to, like for example with temperature. Now, you have to be careful about this, because if the user does not enter an integer, if they entered some string and we try to convert it into an integer, we're going to get an error. So that's why you have to be careful, and we'll actually learn a way of handling that case in the next section. So for now, let's implement the challenge. We're going to read an integer. This should read an integer from the user and return it. The prompt should be empty. So read integer, we're going to obviously call input. The prompt is empty, and we're expecting it to be an integer, so we're going to assume that it's going to be an integer. So we're going to convert that input into an integer, and then we're just going to return it. So just like this, pretty easy. We could have stored this in a variable if we wanted to. Maybe that makes things a bit more readable. So let's say the integer, I guess I'll call it that, and then here I'll return that integer. So maybe this is more readable for you. But now let's do the second one, read float. So this is going to be very similar. We also want the prompt to be empty. So here, let's call input and then convert it into a float and then return that. So I'm going to call this my float because I don't want it to conflict with the keyword float. And then here, we'll just return my float. So now let's run this to see what happens. We can see that this is the user input, an integer, an integer, an integer, and a float, and a float. So this is the input to our program, and then our output is the same because we're just taking in the input and then printing it. Looks like things worked well for us. Now, sometimes it's not that easy. Sometimes we have to do more than just convert from one type into another. This is actually called parsing in programming. It's a very, very common thing. You're going to come across it a lot, so it's definitely worth knowing. So consider this. Suppose we read a line of input that looks something like this, a string 1, 2, 3, where the values are separated by commas. but we want to convert this into a list of strings. So we want it to be a list of 1, 2, 3. Well, that's very easy to do actually in Python. We can take a given string and then call a built-in function on it. On that string, we can call .split, and we can pass in the string, a comma in this case. This is called the delimiter. That means that this is what's going to be used to split this string. It's going to split it here, and it's going to split it here, and the pieces left over are going to be 1, 2, and 3. Those are going to be converted into a list of strings, and then that's the result that we're going to get from this dot split. And now we print it, and that's what we have. So knowing this, let's implement a pretty interesting function. Read integers. It should read a line from standard in without printing anything and return a list of integers. We can assume that every line is going to be in the following format: 1, 2, 3, 4, 5, where the values are separated by a comma. So we want to return a list of integers in this case. Interesting. So the first thing first we should do is read a line. We want this function only to read a single line. Let's call input. And we're not going to print anything, I guess, to the output. So let's store this in a variable. Right now, it's just a string. It's line. So we want to split this, right? So let's call dot split on it with the comma. So this will give us the pieces. You could say this will give us the list of strings. In this case, I'll call it. So it'll be a list of strings where the strings represent numbers. So now we want to convert this into a list of integers, and I'm going to create a variable for that here. It's going to be a list. Now I'm going to go through every string in the list of strings, and I'm going to convert each one into an integer. So we're going to call int on every single string, and then we're going to take this and append it to list of integers. So .append, passing in this integer. If we did this without calling integer on the string, we'd get a list of strings again. That's not what we want. We want to convert every string into an integer and then return that. So let's do return list of int. So now let's run this and see what we get. We can see that we got the expected result. This was the input if you're curious, and our output is going to be this. So these are lists of integers, not lists of strings. Now for a little bit of practice. Let's practice what we learned. We're going to implement a function, add two numbers. It doesn't take any parameters because we're going to be reading the input from standard in. So the function should read one line from standard in, which is going to contain two integers separated by a comma. And we're going to take those two integers, compute the sum of them, and then return that. So we can assume that the standard in is going to look something like this. Every line is two integers separated by a comma. So this function is going to read one line of input from standard in without printing anything, and then let's call line.split with the comma. So now this is going to give us an array of numbers. So let's assume that these numbers are obviously in the form of strings right now, and we want to convert each one. There's only going to be two of them. We're going to convert each one into a number. Let's get the first one like this, and then let's get the second one like this at index 1. Now we can't really, if we add these together, it's going to be string. So it's going to be string concatenation. That's not what we want. We want to take this number, convert it into an integer, not a string. And same thing with the second one, convert it into an integer, and then return the result of this. So this is one way to do it. You could have obviously put these on separate lines and stored them in variables if you wanted to, but this is the core solution to this problem. Let's see, and it does look like it works. So we read this input and we compute the sums of each pairs and then return those. Now let's get into exception handling. It's a very important part of programming in general. So when an error occurs in a program, it usually causes the program to crash. That's not good. And Python is no exception, no pun intended. This happens in pretty much every language. So if you had something like this, 10 divided by 0, well, the program doesn't know what to do. Computers don't know how to handle that because 10 divided by 0 is pretty ambiguous. We don't know what to do, so the program stops, it crashes. So that means here that any code after that is not going to execute. We have a print statement after that. It's never going to execute because this is going to crash the program. But there is a way to handle this in Python and in other languages as well. In Python, it's done by using the try and except blocks. So anytime we have some code that might potentially cause an error, we want to put it in a try block. So this kind of looks like an if-else statement in terms of the syntax, right? So we put the code in the try block. So this, in this case, is going to cause an error. If we had 10 divided by 1, it would not cause an error, but we have 10 divided by 0. It's going to cause an error, and that means that the code in the except block is going to execute. So this is our way of handling this error. It's saying if this causes an error, we'll stop executing that code and instead execute this code. So we would print an error occurred. Maybe we could say you tried to divide by 0, don't do that. That would be a bit more descriptive. But then here we have the try except blocks, and then code outside of the try except blocks. This is always going to execute whether there was an exception or not. An exception basically means an error occurred. So if this didn't cause an error, like if we had 10 divided by 1, the except block would never execute. So keep that in mind. This whole concept is called exception handling, and again, it's used in most programming languages, most modern programming languages. Our challenge here is to implement this function, divide numbers. We're going to divide A by B and print the result. We're not returning anything. We're just going to print the result. But if an error occurs, we're going to print an error occurred instead of printing the result. So let's keep that in mind. Let's implement this here. So we know we're going to try to do result is, let's say, equal to A divided by B. Obviously, this could cause an error. So let's put this in a try block. We can declare that like this, try, and then let's make sure to indent this. And then here, let's put the except block. So we're going to try to do this, and then we're going to try to print the result if we can, but if an error occurs, let's print that string that they wanted to, an error occurred. So here, let's do that, print error occurred. This is the code. Let's give it a run. And you can see it works as expected. So this is just a brief intro to exception handling. Now, we can actually be a bit more specific, like I kind of mentioned earlier. When an error occurs in a try block, it could be useful to know exactly what error occurred. And we can do that like this. In the except block, we can say exception as error. So this is a very generic term. Exception could mean any type of error occurred. And we're saying as error because we're storing whatever exception occurred in this variable. And it's going to give us information about the error, and then we can print that information just like this. We're printing this string, and then we're printing whatever the error message happened to be. So in this case, this is the information it's going to spit out. It's going to say error because that's what we printed, and it's going to say division by 0. So it actually tells us what error occurred. Obviously, you can tell this would be very useful to debug code to figure out what is causing the issue. So knowing this, let's implement the function divide numbers. We're given a string A and a string B. So these are strings, but we want to attempt to convert them into integers and then divide the first number A by the second number B. Now, if an error occurs, we want to print an error occurred followed by the error message. So we're probably going to need to do something like this. So let's try that. There's going to be a variety of errors that could occur this time, actually. We might not just get divide by 0. So let's see what happens. Let's do try, and then in here, let's compute the result. But first, let's convert them into integers. So let's say A int. I'm going to convert A into an integer. I'm going to say B int and convert B into an integer. Then I'm going to try to divide A by B and store it in the result. And then I'm going to try to print it. So print the result. Now, if an exception occurs, let's try to catch that exception. Let's do the syntax as on the left, exception as error, and then let's print it. So they told us to print this message, an error occurred. So I'm just going to copy and paste it here. And I'm also going to print the error message, which is stored in that variable. So just like this. So let's see the output that we get. Let's print it. Whoops, I actually had the wrong variable name, so I had error when we want the actual variable name, error. So sorry about that. Let's give this a go. And we can see we did get the correct output. So the first test case, 10 divided by 2, that gave us 5. Next time we got an error, division by 0. It makes sense because we're trying to divide 12 by 0. Next, we got an error, invalid literal for int base 10, not a number. We tried to convert this string into an integer and it didn't work. So that gave us a different exception, which we handled here. Again, this is the power of exception handling. It can tell us what exactly the error was that occurred. Now, instead of having just a single block to catch an error, we can actually be even more specific. So I told you that this was the generic case. Exception will catch any type of error that occurs, but we might want to handle them differently. So we can actually do that. So with this, we have 3 different exception blocks. We have this one, which is only going to catch value errors. And we have this one, which is only going to catch 0 division errors, and it'll print like a specific message for each case. And then this one will catch every other type of error, so the generic case of errors that didn't match these two. You might be wondering, like, how do you know what type of error could occur? How do you know all the different types of errors? There is a link for that down here, but you don't have to memorize it. Just kind of know that there's all types of errors. And if you need to know which ones they are, you can always kind of research that. But it's generally a good idea to always have at least one generic block, which will catch any type of error if you don't match the specific ones. You'd only want to have a block here for 0 division and for value error if you wanted to handle those separately, if you wanted to give like a very specific message in those cases. So like the way this will execute is if a value error occurs, it'll execute this block and it'll skip the rest of them. If a value error doesn't occur, it'll try this one. If a 0 division error occurs, it'll execute this and skip the rest of them. If neither of these occur, it'll execute this third one for sure, unless like an exception never happened in the first place. In that case, none of these would execute, obviously. So knowing all of that, let's implement this challenge. Divide numbers. It's going to take 2 strings as arguments, just like before. It's going to try to divide the first one by the second one and then print the result. So just like before, except we want to have specific blocks here. We want to have a except block for value errors, an except block for 0 division, and an except block for all other types of errors. So let's do pretty much the same code as before. I'm going to put that in the try block. I'm going to have a int. I'm going to convert a into an integer like this. I'm going to have b int and convert b into an integer like this. I'm going to try to compute the result, take a int, divide by b int, and then try to print the result. Now, there's a few types of cases we have to handle. Maybe an except occurs for value error. And let's just make sure we have the syntax correctly. So value error, we don't really need to catch the error specifically. We can just print this string over here on the left, error invalid value. So I'll just copy and paste that here. We have the other case where we have 0 division error. I'm going to copy and paste that here. And in that case, we want to print this string, error division by 0. So let's do that. And lastly, we have the generic case, which we can handle like this. Except exception, and let's see what we want to print in that case. We just want to print an error occurred followed by the error message. So let's turn this into a variable, except as error, and then print an error occurred followed by the error message itself. So very similar to the previous code. Now we just have different blocks for different types of exceptions. So let's run this now, and we get the expected output.